Neo4j is a powerful graph database that enables organizations to model, store, and analyze complex relationships between data points. Its intuitive graph-based structure offers a flexible and efficient solution for diverse applications, making it a leading choice for managing connected data. This course is taught by FreeCodeCamp team members Farhan Chowdhury and Gavin Lawn. First, you will learn about Neo4j and graph database management systems, as well as how you can benefit from incorporating them into your applications. Next, you will learn how to use a Neo4j graph database management system as the back-end storage for a real-world application created with Java and Spring Boot. Finally, you will learn how to create a front-end with React to interact with the data stored with Neo4j. Neo4j provided a grant to make this course possible. So, let's get started.
Hi and welcome, I'm Gavin Lawn. So, I finally got my FreeCodeCamp t-shirt. I traveled all the way from the east coast of South Africa to Amsterdam and met the founder of FreeCodeCamp, Quincy Larson, and he gave me my own FreeCodeCamp t-shirt. Really great. So the point of the trip was to meet Quincy and some of the core team members of FreeCodeCamp in person. It was about team building and solidifying relationships between co-workers. The key concept in this course is in fact relationships. Relationships between data. The relationships could be between people, between car parts, between a t-shirt and a human being. So relationships between homogeneous data or like data, for example, between human beings, or relationships between heterogeneous data, or different types of data. These relationships can be very effectively represented within a graph database management system. Neo4j is a graph database management system. In this part of the course, I want to present to you a brief overview highlighting the significance of a graph database management system. Before we look at Neo4j, let's contextualize the significance of a graph database management system by looking at some of the other popular types of database management systems commonly used today. So let's look at 3 other commonly used types of database management systems before we discuss the graph database management system, and why we would want to use a graph database management system in our applications. The most well-known used database management system type is a relational database management system. Examples of relational database management systems are SQL Server, Postgres, and MySQL. In this type of database, tables represent entities. For example, a table named employee contains rows of data. Each row of data is divided into columns or fields containing employee information. For example, the name field contains the employee name, the age field contains the employee's age, etc. Another data entity could be implemented in a table named department. Each row in the department table denotes an individual department. For example, one row stores information for the Human Resources Department, and another row stores information for the Finance Department. These data entities or database tables within a relational database can be explicitly related to one another within the relational database management system. For example, an entity may have a one-to-one relationship with another entity. So say employees and the cars they drive. A specific employee is related to a specific car. One employee to one car. So for example, the employee entity in this case has a one-to-one relationship with the car entity. 2 database tables can have a many-to-many relationship. For example, an employee could be a member of multiple teams, and each team can contain multiple employees. So this means an employee can be a member of more than one team, and each team can have many employees. So in this scenario, the employee entity has a many-to-many relationship with the team entity. A database entity can have a one-to-many relationship with another database entity. For example, the department table has a one-to-many relationship with the employee table, meaning each department can contain one or many employees, and an employee can only be a member of one department at a given time. So this one-to-many relationship can be established within the relational database management system through an appropriate schema design. A database schema defines how data is organized within a relational database, which includes constraints such as table names, fields, data types, and the relationships between the relevant entities. So for example, the one-to-many relationship between the department table and the employee table can be implemented by including a primary key, which is a unique identifier for a row of data in the department table, and a foreign key field within the employee table, which relates to the primary key value within the department table. The main advantages of a relational database design is that it helps facilitate data integrity, so the data is not easily corrupted, as well as reduces data redundancy. Storage for repeated values are reduced. For example, if you stored department data within the employee table, you can see here the department short name field and long name field values are repeated across rows in the employee table, whereas separating the data into an employee table and a department table means these values are not repeated, resulting in saving storage space. As the data scales, this storage saving can be quite significant. A technique known as normalization is employed to design a relational database. I won't go into the details of normalization here, but please look up normalization, which is a key concept in relational database design. So the technique of normalization can increase data integrity, minimizing data corruption and also significantly reducing data redundancy, i.e. unnecessarily storing values repeatedly. The downside to relational databases is the speed of retrieving data when multiple joins or deep joins between entities are necessary. For example, if you want to retrieve analytical data that summarizes data from multiple entities, a normalized database design can cause the retrieval of such data to be a slow process. So, a way to speed up data retrieval can be to use a schemaless database management system like, for example, MongoDB. This is a document-based database management system. The fact that the database design is not bound by a schema, like with a relational database management system, can result in increased speed of data retrieval, as well as allow for better design flexibility. So you can see that each of these database management systems have their purpose and advantages. Another type of database management system may use a name-value pair storage structure, like for example Redis. This database management system is great for caching frequently retrieved data and therefore can help speed up a system. So we have briefly looked at 3 common types of database management systems. Relational database management systems like for example SQL Server or Postgres, schemaless database management systems like for example MongoDB, and name-value pair database management systems like Redis. So let's look at the significance of a graph database management system. Neo4j is a graph database management system. This type of database management system is based on the graph data structure. All of these social media platforms use graph databases: Twitter, Facebook, and Instagram. As we all know, these platforms have millions of users. A relational database management system would not be ideal as the only storage facility for such data. Because of the way the data is structured, would mean multiple joins between entities would need to be made when relevant data is retrieved, which would drastically slow down the data retrieval process, ultimately causing a poor UX user experience because the whole system is slowed down by these joins that need to be made between data. So note that when designing a particular system, like a social media platform, you could incorporate both a graph database management system and a relational database management system into your overall system design. This type of solution could combine the enforced data integrity inherent in relational database management systems with the complex relationships between data entities or nodes that can be facilitated using a graph database management system. For example, the master database could be a relational database where data integrity and data redundancy concerns are addressed by the inherent benefits that we have discussed regarding a relational database management system. A graph database management system that is appropriately synchronized with the relevant relational database management system can be leveraged to increase the retrieval speed of data that, for example, has complex relationships. If data that requires complex relationships was retrieved directly from the relational database management system, the joins required when retrieving the relevant data could significantly slow down the system and ultimately result in a very poor UX, user experience. So by including a graph database management system in the overall system where it sits on top of the relational database management system, as it were, and is used to speed up the retrieval of data with complex relationships, This could significantly speed up the data retrieval process, resulting in a far better UX, user experience. So this sort of system would require that the data stored in the relevant graph database management system and the relevant relational database management system be synchronized so as to ensure that the data is consistent across the two disparate database management systems. So a system like this, when designed properly, can leverage the benefits of both types of database management systems. For graph-based data structures, a database management system that focuses on the facilitation of relationships between entities or nodes is essential, and a graph database management system provides a way to store data based on the graph data structure, which is ideal for applications that consume data where entities have multiple relationships and complex relationships with one another. Think about social media platforms where you have relationships between users and posts, likes, friendships, etc., and you have millions of people using these platforms. A database management system is needed that appropriately facilitates the storage of data for a large number of different types of relationships. A graph database management system allows for relationships to be stored as data within the graph database. With a relational database management system, the emphasis is on the entities, and generally the relationships between the entities are not stored in the database, but rather general relationships are established at the design level. For example, you can see by the foreign key field value that the employee is a member of the HR department, but there are no details about the relationship itself between the relevant department and employee saved in the database. This is something you could easily do within a graph database management system. You could create a more detailed relationship. You can easily save data regarding individual relationships between entities or nodes, for example, between an employee node and a department node. So here's a whiteboard presentation that shows how the relationships between individual employees and departments could be represented within a graph database. So here we see a node that represents a department. This node is appropriately labeled department. Details related to this department node can be saved to the database as properties and related values. So this department contains a short name property with a value of HR and a long name property with a value of human resources. Here is our first employee node. This node is appropriately labeled employee. The employee node contains properties and relevant values representing the employee's name and age. Here we see our first relationship. This relationship explicitly shows that the employee, whose name is Brad Jenkins, is part of the HR department. This relationship is appropriately labeled member of. So you can see that this is a very human-readable representation of data. The fact that this employee is a member of the HR department is clear through appropriate labeling and properties. So Brad Jenkins is a member of the HR department. We are able to add properties to the relationships themselves. So the member of relationship has a join date property as well as an employee type property. You can see by this data when this employee joined the department and that this employee has a permanent role and is not, for example, a contractor. Here we have the second employee node, who has the name Jenny Lane. Jenny is also a member of the HR department. We can save relationships between employees within our graph database. So Jenny works with Brad. We can also create another works with relationship in the opposite direction where Brad works with Jenny. So you can see that we have a one department to many employees relationship, just like what was shown earlier in the relational database, but a graph database is far more flexible in terms of design when establishing relationships between data points or nodes. Not only can the entities contain associated data, but the relationships themselves can also contain data, i.e. through properties and associated values. So we could create even more complex relationships between nodes. For example, a chain of command hierarchical structure related to our employee nodes. So here's an example of this where employee James Stokes reports to another employee, Jenny Lane. This is just a simple example, and of course this hierarchical data structure could become far more complex. So this presentation was only intended to give you a basic idea of how much more flexible the design of relationships between entities can be within a graph database, and how complex relationships between entities can be easily implemented within a graph database. I want to show you a brief demonstration of using Cypher to query a graph database, and to do this, I'll firstly create a Neo4j database on my local machine. I'll use my Mac platform to demonstrate this. I'll contrast using Cypher in Neo4j with using SQL in the SQL Server database, which of course is a relational database management system. Firstly, what is Cypher? Cypher can be likened to SQL, or structured query language. Cypher is a text-based declarative language used for querying a Neo4j database. What is meant by a declarative language? A declarative language is a high-level language that describes what a computation should perform. These languages must follow strict semantic rules, must be structured in a particular way, in order to be valid and for desired results to be returned from the relevant database management system. For example, using SQL, in order to bring back all employee records from the employee table, you would appropriately execute the following SQL code. This SQL statement simply returns all rows and all columns from the employee table. Using Cypher, if you wanted to return all employee data, you would use a query like this. This query would return all employee nodes and relevant relationships. Although when comparing these two query languages, they are of course semantically different, but principally they are the same in that the relevant declarative text-based code is parsed by the appropriate database management system, converted into appropriate instructions that are executed under the hood, as it were, and the relevant results are then returned from the relevant database. I'd like to demonstrate using Cypher within a Neo4j database. I'll contrast executing Cypher against the Neo4j database with executing similar queries against a similar database implemented in a SQL Server database. You don't need to follow along with this part of the course, but of course you can if you want to. So if you want to follow along, you can install Neo4j on your Mac or Windows platforms by following the instructions at this URL. I have already installed Neo4j on my Mac platform. If you want to install a free version of SQL Server, please navigate to this URL. But as discussed, this part of the course is only intended to be an overview and not a detailed explanation, so it's not necessary to follow along with this part of the course. I've created these scripts on GitHub for this part of the demonstration. So I'm going to copy this script from GitHub and run it in Neo4j to generate my Neo4j graph database. So within Neo4j desktop, let's create a new project. I'm going to call this project Sample Project. Then let's create a new database. I'm going to name my Neo4j database Company DB. Let's give our database a password. Then let's press the Create button. And now we need to start the database, so let's press the Start button to do this. Then to execute our Cypher queries, let's click this Open button and open the appropriate window from which we can execute our Cypher queries. So the first thing we need to do is copy the code for creating our graph database. So let's navigate to this appropriate GitHub URL. Let's copy this code from GitHub and appropriately paste the code within the window that we can use to run our queries through Neo4j desktop. Great. And let's click the play button to create our graph database. Excellent. And we are presented with appropriate status information telling us that our graph database has been created successfully. I'm going to run this script within SQL Server to generate a similar database, the difference of course being that this database is designed as a relational database. So let's appropriately copy this SQL code from GitHub. Let's launch SQL Server Management Studio. Let's run our SQL code to create our database. I've already created a database named the Company DB Test, so I'm going to create a new database named the Company DB Test 2. Then I need to change the relevant SQL script to point to the new database that I've just created. Let's press the play button to run the script and create our database tables and relevant data. Great. So I'm going to run a few queries so that you can get a basic understanding of the differences and similarities regarding Cypher and SQL. So let's run this query against the Neo4j database. Great, this query brings back all the employee nodes and relevant relationships. In order to retrieve all employee data from within the relevant SQL Server database, you could run a SQL query like this. And let's say we wanted to retrieve particular data about a particular employee. So you could run this Cypher code like this. Within the SQL Server database, you could run a SQL query like this. Okay, so now the next query I'd like to run is a little bit more interesting. So in both these two databases, we have expressed a hierarchical relationship between employees. In the Neo4j database, this is implemented through the report to relationship established between employees. In the SQL Server database, the same hierarchical relationship between employees is expressed, but through the use of what's known as a self-joining table. So in this case, the employee table joins to itself through the relationship between the report to ID field and the ID field, which stores each employee's ID. So in the employee table, the hierarchical relationship between employees is established through the use of the report to ID field, which stores the employee ID of the relevant employee's immediate boss, if you like. So employee Brad Jenkins is at the bottom of the hierarchy, as it were. So if you wanted to query the SQL database to get the chain of command from Brad Jenkins to the top of the hierarchy, you need to run a query like this. As you can see, this query is really difficult to understand at first glance, and recursion is used to get the desired results. A graph database is far easier to understand in terms of retrieving such tree data structures from the relevant database. So to use Cypher code to retrieve the relevant hierarchical data, starting with an employee at the bottom of the hierarchy, Brad Jenkins, you would run Cypher code like this against this particular database. Great. Okay, so I hope this part of the course has given you at least a basic understanding of a graph database management system and how you can benefit from incorporating a graph database management system into your applications. Farhan will now go into more detail, where he'll use a Neo4j graph database management system as the backend storage facility for the server-side part of a real-world web-based application. I will then follow Farhan and create the front-end code for this application using React.
Hello everyone, welcome to this course. I am Farhan Hassin Chaudhry, one of the instructors, and I will walk you through the entire process of working with a Neo4j database, as well as the development of an API powered by Spring Boot framework. Now, at this point of the course, I will show you how you can create a new account for the Neo4j Aura Cloud Database Service, how to create a new database and run some simple queries. Now, keep in mind that this is not going to be an exhaustive list of all the commands and queries that you can run inside a Neo4j database. What I am going to do is I will show you how you can create a node, how you can create relationships, how you can delete a node, update a node, and some other basic CRUD operations. In a word, I will teach you whatever is necessary to create the API. Now, to begin with, we will navigate to Neo4j's website. I will leave the link in the description so you can follow along. And once you are here, you will use the Get Started free button to create a new account. Now start free. And if you wish, you can sign up for a new account using your email address. But what I am going to do is I will just use my Google account to log in. Now I have successfully logged into Neo4j Aura, and I hope you have done that too. So this is the dashboard that they give us. You can see there are the instances that we are going to create. Now to create a new instance of a database, just click on the new instance button and it will give you a free templates. Like if you are a beginner, you can start here and it will give you some data to start with. What we are going to pick is an empty instance because I want to show you how you can create new nodes, relationships, labels, and things like that. So we will hit create. Then they will generate a password for us. Now you can copy that password using this button, or even better, you can use this download button to download all the credentials as a text format. Now I'm not going to do that yet, but I will show you later on how that works out. So once you have copied the credentials, click on confirm. I have copied or downloaded the above credentials so that they will know that you have the credentials, because you cannot get it once you have gone past this step. Now we will do continue. Now the creation process of a new instance is a bit long. It can take around a minute or so. So what I'm going to do is I'm going to pause the recording and come back once the instance has been created. So it looks like that the database has been created. It's running on GCP or Google Cloud Platform. And since I am from Asia, I am from Bangladesh, the region closest to me was Singapore. Now we also have a connection URI. Now to connect to this instance, all you have to do is click on the open button. But before that, just in case you want to rename your instance, you can go here and you can use rename. I'm not going to do that though, so I will just open it and they will ask for a password. So I will just paste in my password and the database user will be Neo4j. You don't have to change any of these things, just click connect. Now once you have landed on your workspace, you will see that there are no nodes and relationships whatsoever. But I would like to show you how you can create new nodes, how you can create new relationships between them, how you can update a node. Now, the Cypher query language is really expressive and this is really easy to learn if you have experience with some other query languages like SQL. But even if you do not have any experience with that, Cypher is not that hard to learn. The Cypher documentation is an excellent piece of resource. They also have a cheat sheet. Now I will leave a link to this cheat sheet in the description of this video. You can visit this and you can essentially learn about how to read all the nodes in a database using the match clause, or how to filter them using where return variables. And under write queries, you can also learn about creating new nodes, labels, and relationships. set for updating them, delete and remove for getting rid of nodes and labels and things like that. I would suggest that you bookmark this Cypher cheat sheet in your browser so that you can refer back to it whenever you need, and also the documentation. Now I will go back to our workspace and I will start creating a bunch of nodes, and I will explain how you can do that as well. So let's switch back to our workspace. And the first thing that we want to do is we want to create a new node. So we will begin with the create clause and a set of parentheses. Then we will put a colon here and we will write the label of the node. So a node is an independent or a single entity inside your database, and it has to be labeled something. For example, if we create a node in our database with the name Farhan Hassin Chaudhary, it will be hard to say what this node represents. Does it represent a user? Does it represent someone's pet cat? What is it? So we are labeling our node with the label user. And then we will put some properties here. The first thing I want to put is a name for this user. So Farhan name colon Farhan Hassin Chaudhary. Then I will put a comma. The next is a username. This is a unique username and we will use it to uniquely identify every single user. So we will say username is just Farhan. And that's all I am going to put here. Now I will execute the command using the play button. And looks like we have a new label here, and if I click on this, it will return everything under this label to us. Now instead of clicking on this label, we can also use the match clause. So we will say match, and we want to match for all the nodes in our database. We will say return all the nodes. Now this is just a variable, by the way. If you want to call it nodes, you can do that as well. Just make sure you are not using any of the reserved keywords. For example, if I remove the s here, you will see it becomes red, which means it's a keyword. Like match and return, we cannot use it. So I will change it back to nodes. I will run the query, and as you can see, we have all our nodes here. Now let's go ahead and create two more users. So I will say create, and this time I want to actually create multiple users with a single create call. So I will keep pressing shift and press enter to come on the next line. I will start a set of parentheses. I will create a new user with the name John, and his username will be just John. Then outside of the last parenthesis, I will put a comma, and I will again keep pressing shift and press enter to come to the second line. And I will open another set of parentheses. I will create another user, and her name will be Jane, and username will be just Jane. It has to be string. Now if I end this query with a semicolon at the end, I can just press on this play button, and as you can see, I have successfully created two new nodes and four sets of properties. So if I say match n for nodes and return n, I can get all the nodes in our database. So I have Farhan Hassin Chaudhary, I have John, and I have Jane. Now the thing is, all these three nodes are of the user label. So it would be nice to have another label on our system. So let's go ahead and create a bunch of courses. Now to create a course, we will use the same syntax as before, and you can use your up arrow to bring back your old queries. And I will just make some changes to this query. I will switch user with course in both cases. I will replace title with C++ course and the username with identifier. This is an unique identifier for the course, which is CPP. And the next course we will have is title JavaScript course, and we can call it JS. Finally, we can have another course called C# course, and its identifier will be C#. Whether I have made a mistake here, it should be identifier and not username. So let's look at our query. We are creating 3 courses with title C++ course, JavaScript course, and C# course. They all have a unique identifier CPP.js and C#. So I execute this command. Looks like I have a mistake, which is I didn't put a comma at the end. And how did I know that? So as you can see, Neo4j is actually telling me that there is some problem in the beginning of the course title C# line, but I can see that it's totally fine. So it's highly likely that the mistake is actually at the end of the previous line. So that's how I thought that maybe I have missed a comma. So I will run this query again, and I have created 3 new nodes, and I will say match n, and I will return n. So as you can see, I have all my nodes here. There is Jane, John, and Farhan, Haseen, Chaudhry. These are the users. And C++, JavaScript, and C#, these are my courses. Now, it would be nice if I could create a relationship between Jane and the C++ course, John and JavaScript, and Farhan, Haseen, and C# course. So I want to essentially enroll them in this course. But before that, I would like to show you a few variations of the match clause. So right now, when we say match n, return n, it actually returns all the nodes in our database. What if I want to only get the course nodes or the user nodes? We can do that by defining a label after this variable like this. So I want all the users, return n as users. You can actually do that. If you use as, you can actually rename your variables to make them more user friendly. So I am matching all the node of label user and I returning them as users. I will press play. As you can see, I am now getting only the users and not the courses. Likewise, I can replace n with c, or let's just keep it n. Since that's just a variable, I'm picking the course as, instead of users, I will say courses. By the way, you can press Ctrl Enter to execute your query without pressing the play button. So right now I'm getting only the courses. But what if I only want to get one user? For example, I only want to match for the user with username Farhan. So I can do that. I can say match u for user. So I'll put user. Then I will use the where clause. This is used for filtering or query results. So I will say where u dot username is equals Farhan, return u as Farhan. So what I'm doing essentially here is I am matching for a user type that has the username Farhan. I am putting it inside u and I am returning u as Farhan. Let's run this query. And as you can see, I am getting Farhan Haseen Chaudhry back. Now let's add a course to the mix. So after I am saying u colon user, I can put a comma, start another set of parentheses. I can say c course. So where u dot username equals Farhan and c dot identifier is equals cpp. So return u comma c. So this time I am removing the as keyword. And what I'm doing here, I am matching for a user and a course where the username is equals Farhan and course.identifier is equals CPP. Finally, I am returning U and C. Let's see if it works. As you can see, we have successfully found the C++ course and the Farhan Hasin Chaudhry user. Now we are actually ready to create a relationship between these two nodes. So I will bring back my old query, and instead of returning them, I want to say create, because I want to create a new relationship, and I will first take the user. So here I have the user, then I will put a dash, then a set of square braces, and inside I will say colon enrolled in. This is the type of relationship this user is going to have with the course. So what we are doing, we are matching for a user and a course where the username is Farhan and course identifier is CPP. Then we are creating a relationship. What kind of relationship, you say? We are creating an outgoing relationship from the user. And how do I know that? As you can see, there is an arrow going out from the user towards the course. So this is an outgoing relationship from the user. And what is the type of this relationship? The type is actually enrolled in. Now we can actually save this relationship inside a variable called R, and I can say return R. So if I press the play button again, yes, looks like I have successfully created a relationship. So the relationship actually starts at node 1 and ends at node 4, which means that the ID of Farhan Hasin Chaudhry is 1 and ID of CPP is 4. If I go to user, you can see Farhan Hasin Chaudhry has the ID 1, and if I go to course, C++ course has the ID of 4. Okay, and the type of relationship is enrolled in. There are no properties whatsoever. There are the element ID, start node element ID, and things like that. We do not have to worry about them. So that's how you can create a relationship between these two nodes. So that's how you can create relationships inside of Neo4j. Now let's see how you can update a property of a node. So if I want to update the name of Jane to Jane Doe and John to John Doe, I can do that. First, we have to find John in our database. So we will say match a variable u of type user, where u.username equals John. So now we are matching for a user with the username John. Then we want to use set. This is another clause in Neo4j Cypher language. So I will say set u.name equals John Doe. And if I execute this query, looks like it has done its job. So if I go back and instead of setting it, if I return u, John has now become John Doe. We can do the same thing with Jane, because why not? They are related. Jane, and we can say Jane Doe. Okay, so I want to return Jane, return you. There you have it. So now you have learned how to match nodes in the database. You have learned how to create new relationships, update values of an existing node. Now that's pretty much all you are going to need for the API development process, but I would like to show you one last clause from the Cypher query language, and that is the exist clause. For example, if you ever want to check if Farhan Hassin Chaudhary is enrolled in the C++ course or not, you can do that using the exists clause. So we will begin with match. And what do we want to match? We want to match for an user and we want to match for a course where u dot username is equals Farhan and c dot identifier is equals CPP. Now we have an user with the username Farhan and we also have a course with the identifier CPP. Next, what we want to do is we want to say return and we will call the exists function. This is a function and that's why we have these two parentheses, and inside these parentheses we want to describe a relationship. So the relationship we are looking for or checking for is whether user is enrolled in the course or not. Okay, so we will finish our query. What we are doing, we are matching for a user with the username Farhan and we are matching for a course with the identifier CPP. Then we are checking whether a relationship between them of type enrolled in exists or not. So I'll press the play button and it says true. Now, if I switch CPP for something else like JS, we have the JavaScript course, and I hit the play button, you will see I'm getting false. Now, to be honest, that's all you need to know to go through this entire course, but Cypher is a really excellent query language, and if you have plans to learn a lot more Neo4j than I have showed you in this course, I would suggest that you go through their documentation, you go through their cheat sheet, and you practice making your own databases, querying them in a lot of different scenarios, and learn as much as you can about this database system. Now I'm going to finish this lesson here, but in the next lesson you will see me using an initializer Cypher script to create a new database for our API, and from there we will begin working on our Java code. In this part of the course, we are finally going to start working on our Spring Boot API. But before that, we need to set a few things up. First thing first, go back to your Neo4j Aura database dashboard and delete any old instances that you may have created. While working with the API, we want to start with a clean slate so that we can be sure of the fact that some old data will not mess up our API. To delete an old instance, you can use the delete button here, and then you will have to write the name of the instance. It's just to make sure that you are in your right senses and you are not sleeping or anything. Click on the destroy button and wait until the instance is being destroyed. Now, to create a new instance, use the new instance button. Choose empty instance and click on the create button. Make sure you download the credentials file because we are going to need it later on. And also let them know that you have downloaded the credential file by clicking on this checkbox. Click on continue. Now creating a new instance may take a few minutes. So what I'm going to do is I'm just going to speed up the process in this video so that you don't have to wait around for long. Once the instance has been created, click the open button, accept their terms and conditions, and when they ask for the password, open up the credentials file you just downloaded. Just highlight the password here, copy it, and paste it on the empty password field. Click on connect. And we have successfully connected to our new instance. Now, as you can see, this instance is completely empty, but we will need some data to work on our API. Now, for that, I have already created an initializer script that you can use to initialize the database. For that, go to the code repository on GitHub. I will leave the link on the descriptions below. Then go inside the data folder. You will find a file called initializer.cypher. Open up this file and go to raw. Highlight all the lines and copy with Ctrl+C. Then go back to your RDB dashboard. Paste the code that you just copied and then press the play button to execute the code. As you can see, the code has successfully created some nodes, relationships, and property keys. Now, the first node that I would like to show you is the user node. Now, this represents all the users in our database. For example, if we open up John Price, you can see that it has an ID, it has a name John Price, it has an encrypted password hash, it has roles, and it has username. Now, the significance of each of these properties will become more clear as you start working on the API. But for now, just keep in mind that all these properties are important for our application. Next up, we have course. Now, this represents each of the courses that will be available on our system. So if I click on the Blazor shopping cart course, you can see that it has an ID of 10. It has a string identifier that we are going to use to uniquely identify this course. It has the name of the teacher and a title. Now, you may argue that we can use the ID to uniquely identify this course. While that's correct, I prefer using some other unique string or identifier to identify my course or entities. I just do not like to rely on the auto-generated ID fields in any database at all. Finally, we have the lessons. These are the individual lessons that belongs to some course. For example, if we click on the Blazor WebAssembly and Web API on .NET 6 lesson, you can see it has an identifier. Just like the courses, it has a title and it also has an ID. Now, this lessons here has a belongs to relationship with the courses, which means each of these lessons belongs to a certain course. For example, if I zoom in on the Blazor course, as you can see, all these 4 lessons belongs to the Blazor shopping cart course. Finally, there is the enrolled in relationship, which is between the individual users and courses. So, for example, John W here is enrolled in the Blazor shopping cart course. Now that we are done with our database, we can finally start working with our API. For that, you will need JDK pre-installed on your computer. Now you can download the JDK from Oracle's website. I am going to use JDK 17 since that's the latest long-term support release. But you can also go with JDK 20. It's totally up to you. One more thing for those who are watching this course on Linux, it's totally fine to use any of the OpenJDK builds. For example, I myself am using the Microsoft build of OpenJDK instead of Oracle's official build. And given the complexity of our API, it's not going to make any change or it will not break anything whatsoever. So feel free to use any OpenJDK build that you like You will also need a good IDE to make your programming process more fun. I'm going to use IntelliJ IDEA Ultimate here. I have a student license, so I'm going to use that. But if you want, you can also use the community edition. To be honest, if you look at the feature comparison here, most of the essentials are available under the community edition. We do not need the HTTP client thing since we are going to use a third-party client anyway. We do not need database tools or SQL or any of these things for this project at least. Finally, we need to initialize our project. For that, we are of course going to use the Spring Initializer. Now, I will leave the link to Spring Initializer down in the description. So once you have navigated to this page, we will make some choices here and we will generate our project boilerplate. First, make sure that you are picking Maven under project here. You can also use Gradle if you have previous experience with the tool, but I'm just going to pick Maven. The language will remain Java. For the Spring Boot version, I'm going to use 3.1.0 since that's the latest at the time of recording. But if some other version comes out later on while you are watching this course, feel free to use that. Just do not pick any of the snapshots. Pick and stable release. Now under group, you will have to type or you should type some domain in reverse order. For example, my own domain is farhan.dev. So I will just type in dev.farhan. Then artifact is just a project name. So I'm going to call it Spring Boot Neo4j. You may call it anything that you like. I will also put a sensible description like a simple API powered by Neo4j. Finally, make sure that you are picking the correct Java version from down here. I'm going to pick 17 since that's what I have installed on my computer. But if you have installed 20, make sure that you're switching to 20. For packaging format, we will go with jar since that a lot widely used than var format. So let's not change that. Now the most important part, adding dependencies. Now this is needless to say that we will need a number of different dependencies for our project, but for starters, I will just pick Spring Web and the DevTools. Now you may think that why not pick the Neo4j dependencies while we are here? Well, I could have picked them, but one thing that I have noticed in the past is that many people face difficulties while they try to add new dependencies to a project that they have already initialized. So I thought, why not start the project with just the bare bones, essential dependencies only, and then as we go forward, we will keep adding new dependencies to our project. That way, it will represent a much more realistic, development workflow, and it will also teach you how you can search for new dependencies and add them on the fly. So take a good look at all the choices you have made, and once you are happy with them, click on generate. It will download a little zip file to your computer that contains all the project file. So I'm going to just open up the zip file using Windows Explorer or WinRAR or whatever you like. Copy the project folder, go to a place where you usually put your codes in. I usually put them in individual directories, so I'm going to paste it here. And once I have done that, I will just open up my IDE, which is IntelliJ IDEA. I will open up my project. Spring Boot Neo4j. Okay. Yes, we trust the project. And once you have opened the project for first time, I would say give it some time to cache all your dependencies, read the source files and things like that, so the IDE knows about your project and it can help you along the way. Hello everyone, I am your instructor Farhan, but I am from future. Now, in the next lessons, you may see a little problem with the video. In some cases, when I am trying to create a new class or maybe a new package, you may see that this menu is not showing up. Now, this is because my recorder was only recording one window in my computer, so all these sub menus were invisible. So whenever you see me creating a new package, all you have to do is right click on your main package, go to new and then package. Likewise, when I'm creating a new class, you have to pick Java class from here and you can switch between interfaces and classes right from this menu. Another thing that didn't work in my previous recording was the code generation thing. So whenever you are creating a new model, you can use the alt insert key combination, inside the class, of course. Let's get rid of the constructor and you can use alt insert and you can then generate a constructor. You can generate getters and setters and equals and hash code, toStrings and all those boilerplate methods. So what I did in those videos is I picked constructor and then I just ignored all these properties since we are trying to create an empty constructor and then press OK. So a good chunk of the course, if you see all these submenus are invisible, just don't be alarmed. It was some problem with my recorder. Everything should work as is in your computer. Now back to the past. As you can see, IntelliJ IDEA has finally finished resolving all the dependencies in my project, so I am finally ready to write some code. Now, before we start writing Java code, I'd like to address something really important. I hope that you remember back when we were generating our project, we didn't add all the dependencies to our project because I wanted to show you how you can manually add dependencies later on. So this is the time we do that. First, open up your pom.xml and find this dependencies part. Inside that, you can see that there are 3 dependencies already described. You may recognize the Spring Boot Starter Web and Spring Boot DevTools dependencies from a few moments ago when we added them to our project. But there is also another thing called Spring Boot Starter Test. Now this is for testing our code, and in this course we are not going to talk about that. Now the first dependency that we need to add to our project is called the Spring Boot Starter data Neo4j, and the group ID will be org.springframework.boot. Now IntelliJ IDEA is being really generous here and helping us out with writing the dependencies, but I would suggest that you make sure that you are typing them out correctly, because if you make a typo or write wrong name, then you may end up not getting a dependency, or even worse, getting the wrong dependency. Now the second dependency that we need is called the Neo4j Java driver, and the group is org.neo4j.driver. Now whenever you add or remove a dependency from your pom.xml file, you have to right click on the pom.xml file, find Maven and reload project. Depending on how many dependencies you have added or removed from your project, the resolving process may take a while, but in my case, it has finished in a flash. Now I will close the pom.xml file and start creating the packages that we will need. Now inside our main package, dev.farhan.springboot-neo4j, it may be something else in your case, but inside our main package, we will create 4 new packages. Now the first one will be called config. Then we will create another package called models. Then we will have the repositories. Then we will have the services and our controllers. Now, these are not the only packages that we are going to need. We will also need some packages to hold our query results, our data transfer objects, our requests, and things like that, but we will work on them later. For now, these are the ones that we need. Now, once you have all the package ready to go, let's create the model for our first node, which in this case will be the course. So let's create a new Java class and call it course. Then inside, we will define all the necessary properties of this class. So the first one is an ID, and it has to be of type long. Then we will have private string identifier, which we will use to uniquely identify our courses. Then private string title and private string teacher. Then we will create a constructor. Now you may write the constructor by hand, but inside IntelliJ, you can just press on Alt and then insert to bring up this nice generate menu. From here, you can select constructor. And for our constructor, we will not select any of the properties. Now for Spring Data Neo4j, this is one of the requirements that you create an empty constructor inside your model classes. So this is what we are going to do. Then we will say Alt Insert and we will select getters and setters. And we will highlight identifier, title, and teacher. We will not highlight ID, and why you will understand in a bit. Click OK. And now we have all the getters and setters for our private properties. Now, creating a class like this will not suffice. We will also have to annotate this class with the node annotation. This way, Spring Boot will know that this class is actually a Neo4j node and has to be managed by the dependency injection system. Then, inside the class, we will also annotate the ID with two separate annotations. The first one has to be the ID annotation to let Spring Boot know that this is the ID for the node. And then we will say generated value, which means we want this value to be automatically generated and we do not want to write it by hand. Now, since this ID is an automatically generated value, we do not need a setter for it. And since we are not going to use this to uniquely identify our course, we are going to use this string identifier instead. We can just get rid of the getter as well. So now that we have a course class, the next thing to create is a repository. So let's go inside the repositories package, go to new Java class, and we will call this course repository. And it has to be an interface, by the way. Once you have created the interface, it is going to extend the Neo4j repository interface, which comes with our dependency. And this is a generic, and inside we will write the name of the class that we are working with, which is course. And we will also write the data type of the ID of this course. So in our case, it will be log. Now this way of creating a new repository is nothing unique. to Neo4j. Actually, if you have experience with Spring Boot in the past and you have worked with databases like MongoDB or MySQL, you may have created interfaces like this. Now let's close our repository and model, and let's go inside our service. We'll create another Java class called course service, and we will have to annotate this class with the service annotation. Then inside this class, we will need a reference to our course repository. So we will say private final course repository, you can name it anything. And then we will generate a new constructor where we will take the repository. Now that's it. Now since we have annotated this service class with the service annotation, and also the repository extends the base Neo4j repository, this will be automatically injected into our class. Now inside here we will create another public method. We will say public, and it is going to return a list of courses. Get all courses, you can name it anything, by the way. Then we will say return course repository dot find all. That's it. Finally, we will create a controller. By the way, if you think that I'm going too fast, just be patient. Once I have created the model, repository, service, and controller for the course, I will explain the entire workflow or the architecture of the application, what I'm planning to do, and what you should do in any of your Spring Boot applications. So finally, I will create a controller, new Java class, and it will be called course controller. Now I need to annotate this class with the REST controller annotation, so Spring Boot knows that this is actually a REST controller and this is going to describe a few endpoints. Then I will say request mapping. This is another annotation, and I will describe the general endpoint. So I'll say /API/v1/courses. Excellent. Now inside this public class, I will create a private reference to our service class. So I will say private final course service. Then I will generate my constructor, and I will create my first method, which will be public, and it will return a response entity. Yes, response entity of type list course. Now I'll explain what it is in a bit. Just hold on for a little longer. And I will call my method course index. You can call it anything. This is just going to list out all the courses in our application. And then we will say return new response entity, and inside here I will call course service dot get all courses, then comma http status dot ok, end with a semicolon. Then I will also have to annotate this class with a get mapping call and this. Okay, let's take a final look at our application and make sure that the code is working fine. Yeah, that looks okay. Now we have a model that describes the course node in our database. And as I have said a few times already, in our database, the courses have an ID, which is an auto-generated field. We have a string identifier, a title, and teacher. Then we will need an empty constructor for all our models. Then we have some getters and setters. To work with this model, we create a repository interface, which in turn extends the Neo4j repository interface. Now, what is this interface actually? To see what this contains, we can press on the control button and then click on this repository. Once you are inside the source code, you can see it gives us a few useful methods, and one of them is find all. So whenever I'm going to call find all in this repository, it will actually return all the courses in our database in a list format. As you can see, it says list T. There is also find all by ID. There is also find all with a sort functionality, so we can sort the courses. So this is what a repository holds. There is also a save all method, but let's ignore that for now. Now, since we have a repository, we can use it inside a service. You do not want to use your repositories inside a controller directly because that's not a good thing to do. You should always create a service layer that talks to the repositories and use that service inside your controller layer. Always remember that controllers should be responsible for taking and giving back data. They should not worry themselves about the underlying architecture of your database or your models or anything like that. So in this case, we have a service class that makes a reference to our course repository, and we have a single method that gets all the courses for us. One thing that I'd like to mention here that you may have seen the auto-wired annotation that comes with Spring Boot, and maybe instead of creating a constructor like this, I could have just annotated this field with auto-wired, but in some cases that's not the best thing to do. Now, since we have our service, we will go to our controller that describes a single endpoint, which is API/v1/courses. Inside this method, we are just returning a new response entity. This is one of the classes that comes with Spring Boot, and you can use it to return a response to the user. And this response entity thing takes two things. One is body and the other is the status code. Now for body, we are giving it the list of the course since it's a response entity of type list course. And for status code, maybe we have written 200 by hand, but instead of using some magic number, what we are doing here, we are using the value of OK inside HTTP status. This is actually an enum. This enum here actually describes a lot of other status codes. As you can see, it has continue, it has switching protocol, processing, checkpoint, OK, created, accepted. We are going to use created very soon, no content, and a lot of other things. So we are going to make use of this enumerator a lot in our application. So technically our application is ready to run and give us the list of courses, but we have to make one final adjustment, and that is we have to let the application know about our database that we have created earlier. For that, we will need another dependency. Now the dependency that we need is called spring.env. So we'll say dependency, and inside artifact ID, we will write spring.env. And inside group ID, we will say me.paulschwarz, schwarz. Okay, and we will also describe a version for this dependency. It's a version 3.0.0. We'll save the pom.xml file and use this little button here to load the Maven changes. Let's click that and wait until the dependencies are being loaded. So as you can see, it has turned white from red, which means the dependencies have been loaded successfully. Next up, we will create a very simple env file inside src main resources. And we will just right click on the resources folder, new, and file. we will call it .env. Now this env file will contain three values. The first one is aura URI. The second one is aura user, and the third one is aura password. Now, as you may have already guessed, the aura URI is the URI to our Neo4j server on the cloud. The aura user is the name of the user or the username, and finally the password is for the password for the database. Now the aura user is going to be always Neo4j, and I will just quickly copy the URI and password from my Neo4j credentials file. Okay, so I have copied my URI and password from my credentials file, and these are going to be different in your case since your instance is different from mine. Now, once you have created this .env file, next up, you will need to open the application.properties file. Now, inside, we are going to reference the three env values that we have. So I will just say spring.neo4j.uri and then a $, curly braces, and aura URI. Next up is spring.neo4j.authentication.username. Again, another $, curly braces, and aura user. Finally, we will say spring.neo4j.authentication.password. So $, curly braces, aura password. Now, why did we do this? Why we didn't just put all these values inside our application.properties class? Now, the thing is, these values, the URI to your instance, the user password, and the username are secret values. These are things that you should never put on your GitHub repository. Since the application.properties file is a part of your application, we will not put our secrets directly into this file. Instead, we are going to create an env file, and these three variables will be loaded into our local environment, and then the application properties will be able to find them using this $ and curly braces syntax. This is how you actually access any of the environment variable inside your application. Now, I would suggest that you also make a copy of this file and call it .env.example. Then get rid of these values. Save the example file and make sure that your .env file is being ignored inside your gitignore file. So inside here, I will say .env and I'll say .env. So this will make sure that the .env file is not added to your GitHub repository. Instead, you will have an example file that you can use as a reference to create a new env file. Okay, so since we have our model, controllers, repositories, and services in place, and we also have our env file created, our application should be ready to connect to our database and give us a list of the courses. Let's test it out. Now, to do so, you will have to click on the play button. So far, it looks like the application is running fine. So what we are going to do is we are going to switch to an HTTP client called Insomnia, and we will test out our application by sending a request to it. Now inside Insomnia, the first thing that you should do is create a new folder because we want to keep our requests organized. Now I will call it Spring Boot Neo4j, and I will move, or just let's get rid of this request. Now inside this folder, I will create a new HTTP request. This is going to be a GET request, of course, and this is going to HTTP localhost 8080/API/v1/courses. I hope that you remember. And let's also rename this to get all courses or something like that. Get all courses. It really doesn't matter, to be honest. Now let's send a request. Yeah, and looks like we have our list of courses. As you can see, we had 4 courses in our database, and all of those are being taught by Gavin Long, and the list contains all of them. And we also have a 200 OK status code. I hope you remember that we had added that little status, HTTP status dot OK at the end. So that's why you are getting the nice 200 OK response here. So congratulations on creating your first API endpoint in this application. Next up, we are going to work on the lessons, and we will implement the relationship between the lessons and the courses. And we'll also make sure that we can see the details of these individual courses along with the list of the lessons. So I am back at IntelliJ IDEA once again, and now we are going to start working on another endpoint for our application. So let's go back to controllers. Now the next endpoint that I want to work on is an endpoint that's going to return the details of a single course. So if I go back to Insomnia, let's make a copy of this request, get single course, and we will just pick an identifier from all courses request. We will put it inside the single request, and we want to make something like this. Now I actually like to start working from the lowest level of our application, which in our case are the repositories. So I will go back to course repository, and inside we are finally going to create a custom method. Now this custom method will return an optional course, and we will call this method find course by identifier, and then we'll take string identifier. Now the nice thing about these Neo4j repositories is the fact that they are really smart. So just by the name of this method, find course by identifier, Spring Boot will know that we are trying to find a course by using identifier property. And we will also need to pass the identifier by string. Now if I remove this part and I write it again, I will say find, and as you can see, IntelliJ IDEA actually recommends me that find course by. So it can sense that maybe we are trying to find a course by some parameter. So I'm going to pick find course by, and then now it started to suggest me the possible property names, and from this list I am going to pick identifier, and inside, of course, we are going to pass the identifier. I'll say string identifier. Okay, now we have the repository method. We will go back to our service, which is the one step higher level of a repository, and we will say public course, and we will call it get course by identifier, and we'll take the identifier as a string. Now inside the method we will say return course repository dot find course by identifier. Now I hope that you remembered that the method actually returns an optional type, and we are trying to return a course object from this method. So what we are going to do in the second line, we will say or else throw. So if you do not find this course, or if you do not find a course by this identifier, throw side there, we'll create a new lambda and we'll say new response status exception, and we'll say http status code dot value of 404. So what we are saying is, first use the find course by identifier method inside the course repository and try to find a course by this identifier, the identifier that I have passed. And in case you do not find a course using this identifier, please throw a 404 not found response exception status. That's what we are doing. Let's close this service. And inside our controller, we will create a new get mapping public response entity of type course, and we can call it course details. It has to be a get mapping, and it will give us an identifier. So we will get the identifier from here, and inside course details I will say path variable, which means we are going to get a variable from the path, and it will be string identifier. Yeah, that's it. You can call it anything else if you want. Now inside the method, what we are going to do is we will say return, or let's just create a course equals course service dot get course by identifier. We will pass our identifier right here, and then we'll return a new response entity, and we are going to say the course is the body and http status dot okay. Yeah, so that's it. What we are doing here is we are getting an identifier in our path. We are passing that identifier to our service layer. That service layer in turn will call our repository and get us the course that we are looking for. Now essentially this should work. So let's try out. Let's rerun our application. Go back to Insomnia and let's execute the get method that we created a bit earlier. Let's hit send. So as you can see, it actually returns the course that we are looking for. And if we try to look for a course that doesn't exist, for example, if I add some garbage here, as you can see, we are getting a 404 status. Now we are also getting a trace with it. We may configure our exception responses later on, but for now we will just leave it like that. Let's get rid of the garbage. Let's send once again, and yes, we are getting the course details. Now the thing is, the response in the course detailed request and the course list request is pretty much the same. I think it would be nice if we could get the list of the lessons that belongs to this course inside this details response, right? let's do that. Let's finally start working on our lessons. So I'll come back to IntelliJ. I will create a new model. New Java class, and it's going to be called lesson. This is going to be a node just like before. It will have a long ID. Is going to be the ID and also a generated value. Okay, so I will have to import the I think there's something wrong with the ID. Yeah, ID, sorry, it didn't get imported first. Yeah, next we will say private string title and private string identifier. So these are the three properties that we need. Next up, we will generate our empty constructor and our getters and setters. Yes. Now, before we try to implement our relationship between the lesson and courses, let's go back to our database and have a look at how it was mapped. Now, if we focus on a single course here, as you can see, this course has 4 lessons, and each of these lessons has a belongs to relationship with the course. Now, from the point of view of a single lesson, it has an outgoing relationship of type belongs to with its parent course, and from the point of view of the course, it has an incoming relationship of type belongs to with the lesson. Now, with that information, we can actually implement these relationships in our models. Now, back in our code, we will open the source code for the course model, and we will describe a new property, private list of lesson called lessons equals new array list. Now, this list here is going to be a relationship. This is another annotation that comes with the dependency that we have used, and the type of the relationship is belongs to, like we just saw in our database, and the direction from the point of view of the course, it's an incoming direction or an incoming relationship. So the type of the relationship is belongs to, and the direction is relationship.direction.incoming. Now we will need a getter. We do not need a setter since we are not going to set this relationship manually. We just need a getter. Now, since we have implemented the relationship, we have implemented the getter, it should work. Let's rerun the application. Come back to Insomnia, make the request once again. And as you can see, now the course comes back with a list of the lessons. As you can see, this Blazor shopping cart app course has 4 lessons. Now, this is all nice and cool, but there is a simple problem. So if I go back to the get all courses and make a request, as you can see, all the courses are coming back with the lessons. Now, depending on what you want from your application, this may be something that you expect or you do not expect. For example, in some places in my application, I may not want the list of the lessons at all, because whenever a course is coming back with the list of lessons, it's actually querying for all these lessons. So if I do not use the lessons, that entire query time, that time my server is working is going to waste. Unfortunately, there is no way that I know of to leave out a relationship from a query. So if you describe a relationship like that, you cannot actually lazy load it. Every time you will query for the courses, you will also get the relationship back. Now, this is something that's not that hard to solve actually. We can write custom Cypher queries to query for the lessons when they are needed and leave them out when we don't. To do that, first let's get rid of the relationships from the model. Also remove these because we are not going to use them. Now at this moment in our code base, the courses and lessons are totally unrelated to each other. But we have to implement some sort of relationships between them. Now my idea is that we can have them unrelated in our code base, but what we can do is we can actually create another repository. It will be another interface. Let's call it lesson repository. It extends the Neo4j repository. The object will be lesson and the ID will be long. And inside this repository, we will implement another function that is list lesson. This is going to be the return type. Find lessons by course identifier, and we'll get the identifier as a string. Okay, now we have a method that is going to find a bunch of lessons using a course identifier. Now the course identifier part is not a property of lesson, so we cannot have an automatically built method like this. Instead, what we will do is we will write a very simple Cypher query. So we'll say query, then inside, let's begin, we'll say match, and inside a set of parentheses, I will say colon course. So we are looking for all the nodes of type course. Inside I will say identifier. So we are looking for a course node that has the same identifier as we have passed to this method. Now, once we have found this course, we will need to get an incoming relationship R of type belongs to, and the related node should be lessons lesson, and finally we have to return the lessons. Now let me explain what we are doing here. First, we are trying to find a course node that has the same identifier as the one we have passed to this method. Then we are looking for all the lessons that are related to this course using an incoming belongs to relationship. Now, once we have found all the lessons, we are putting them inside another variable called lessons, and finally we are returning the lessons. In fact, we can get rid of this R variable here since that's not being used anywhere. So the only piece of variable that we need is this one here. Once again, we are finding a course by the identifier that we have. Then we are looking for all the lessons that has an incoming relationship with this course of type belongs to, then we are putting those lessons inside the lessons variable and returning them to the user. So this is the query that we have. Now, if everything goes fine, it should return a list of the lessons. Okay, the repository is all set. Let's create a service. Lesson service. This is going to be a service class. And inside the class, we want a private final lesson repository. We will have our constructor, and we will have public first the list of lesson. The name of the method should be get all lessons by course identifier. We will get a string identifier, and then inside the method we will say lesson repository dot find lessons by course identifier, and we will say identifier. That's it, and we can just return this directly, and yeah, that's it. That's all we need in the lesson service. Then inside the controllers, as you can see right now, we are returning a course. Now this is all right, but what would be better is if we return a DTO or a data transfer object. So I'll just rename my config package to objects because we are not going to use the config right now, refactor. And we will create a new class called course DTO. So this is a plain Java class. Inside I'll say private string identifier because I want the identifier for the course. I want private string and title. I want the title for the course, private string teacher, and private list of lesson called lessons equals new array list. Excellent. Oh, it looks like we have to import the lesson class. Yes. Finally, we will have our constructor, an empty constructor for that, because we are going to insert all these values later on. Or you know what, we can get all this like this. Constructor identifier, yes, let's take these three and leave out the lessons because we are going to fill it up later. Next, we want to create some getters. We'll need getters for everything, and we'll need a setter for the lesson. Yes, so that's all we need for the moment. Now let's go back to the course controller. Inside this method, instead of returning a course, I will say course DTO, and I have the course here. Then I will create course DTO response course another object equals to new course DTO. First, I will need course dot get identifier. Next, I need the title, so course dot get title, comma, finally course dot get teacher. Yeah, those are the three. And then I will say response course dot set lessons, and now we need to bring in our private final lesson service here. We need to add lesson service, and inside our constructor I'll set this dot lesson service equals lesson service. Yeah, so we have that initialized. This looks fine to me. Now inside response course dot set lessons, I'll say lesson service dot get all lessons by course identifier and course dot get identifier. So I will get all the lessons inside this course. Finally, in the return statement, instead of course, I will just say response course. Now, technically, if we have written everything correctly, this should give us the list of lessons along with the other course details. So I'll just restart my application. It has been restarted. Let's go back to Insomnia. Send a request for a single course. And as it looks like we are still getting the list of the lessons, but if I go back to get all courses, as you can see now, there are no lessons at all. So inside single course, I can get the lessons because I want them to be there. And inside get all courses, I do not need them, so I don't have them at all. I hope you have understood how you can write a simple custom Cypher query inside Java, and this is going to be really helpful. Now creating this course DTO class, and later on we are going to also create query results class. These all things may seem like a lot of work to you, but to be honest, once you have everything set up, you have the code ready to go, you will see how easy it is to make changes, because you are making sure that you are abiding by the separation of concerns and things like that. So okay, we have done that. Now one thing that I'd like to say, that the way the front end of our application has been created, we actually need the list of lessons in the list of courses as well. So what I'm going to do is I'm going to make some changes to it, this list or the course index method, and make sure that we are getting the list of lessons there as well. So I will change it to a course DTO, and yes, the old return statement won't work anymore. So I will copy this. I will say list courses, courses, and I'm getting a list of all the courses in our database. Then what I'm going to do is I'm going to create another list of the course DTO type, and this will be the response courses equals, I will say courses dot stream. So I'm going to use the stream API of Java. Then I will call map. Now inside map, I will say course. This is going to be a lambda actually. And here I will create a new course DTO. Course DTO response course equals to, I can actually copy this entire line. Yes, then I can also copy this line, put it after this. Yes, response course dot lessons dot service. So now I have a new course DTO, and I'll need to return this. So I'll say return response course, and finally dot collectors.toList. So what I'm doing here, I am getting the list of courses from my database without the lessons. Then I am mapping through that list, accessing each course inside that list of courses. I am creating a new DTO object. I am getting all the lessons for that course and setting that inside my DTO object. And finally, I'm returning that response course from inside this lambda function. And once I have returned that, I am creating a new list and adding that new response course to that list. This is how it goes. Finally, inside response entity, I will just replace this part with response courses. HTTP status OK. Let's save our code and let's restart and see if it works fine or not. Let's go back to Insomnia. Make a request for all the courses. And as you can see, all the lessons are back in the course class. So this far, we have finally implemented the courses. We have implemented the lessons. We have written some custom Cypher query. So I think you have done a lot of work already, to be honest. Now, next up, we are going to implement the user model. We will introduce an authentication system to this application so that users can log in. And once that's done, we can finally work on the course enrollments. So let's continue working on it. Now that we have finished implementing the courses and lessons, it's time to finally work on the user. Now, before we start writing our code for the user-related functionalities, we will need to add a new dependency. So open up your pom.xml file. Then right after spring.env, add a new dependency. Now the name of this dependency will be Spring Boot Starter Security. And its group ID will be simply org.springframework.boot, like all the other starter packages. In fact, let's do one thing. Let's cut this chunk of code from here and put it right after the starter data Neo4j. That way we will have all our starter packs in a line, and then we will have the other dependencies. So once you have added this dependency to your project, just hit this load Maven changes button. Okay, it looks like the dependency has been resolved. Now let's try to restart our application. And you should see something like this using generated security password. The generated password is for development use only and things like that. So this means that Spring Security is actually working. Now to test it out, we can go back to Insomnia. We can send one of our old requests, and you will see that it says 401 unauthorized, which means that the Spring Security system is stopping us from accessing this endpoint. Now this is totally normal. By default, Spring Security stops all the requests to the server, but you can use an username and password to get access to the data you want. Now for that, let's go back to our IDE. Look for your application.properties file inside src main and resources. Now, after the 3 lines that we added before, we will have to add 2 more lines. These are spring.security.user.name, and I will set it to Farhan. Spring.security.user.password equals to password. Now let's go back to Insomnia. Here you can see there is the auth menu right besides body. So I will go inside auth. I will click on this arrow and pick basic auth. Now inside here, I will add the username Farhan and password is password. Then I will send the request. Okay, it looks like we forgot to restart our application. So let's do that. Now Insomnia, send the request, and it worked out just fine. But I know what you are thinking. This is not the right way to authenticate any request. We want to use the users in our database, right? Don't worry, we are going to do that. But before, I just wanted to show you how you can make a request go through the Spring Security gate. Now let's disable the authentication. Okay. Let's go back to our IDE and start working on a proper authentication system. First, let's remove these 2 values. Close the properties, stop our application, and minimize the terminal. Now we will start by creating a new model named user. Now, unlike the models that we have worked on before, the user is going to implement an interface. So we will write implements user details. Now, this interface is actually part of the security package that we just added, and it describes a few methods and properties that makes this model usable for our authentication system. So we can hover over it and it says implement methods. We will click that and it shows us a bunch of methods. We will say okay. And now we have a lot of overrides. Let's just close this sidebar for more space. Okay, so these are the methods that we want to implement. So let's start with get password and get username because those are the easiest one. We will say private string username, private string password. Then inside get password, we will return password, and inside username, we will return username. Excellent. Now those 2 have been taken care of. Next, we will add the roles. So we will say private string roles. I hope that you remember from our database view from before that every single user has a bunch of roles. So this is what we are going to do here. Now, once you have added the roles, we want to implement the get authorities method, which is this one. Now, this is sort of a special kind of method that actually returns all the authorities or roles for this user. Now, you may have seen that I had added a role user value to our users in our database, but you can have something like role admin, role teacher, and so on. You can also have role admin, comma, role teacher, role moderator, and so on. But for now, we are dealing with a single role. Now this method here, it returns a collection and that extends the granted authority interface. So what we need to do is we will say return, we will need the arrays class from java.util, and then we will say .stream. Inside the stream method, we need our roles. So the roles that we have defined here, we'll say roles dot split, and we want to split it by a comma, because remember, we can have roles like this: role admin, role teacher. So we want to split it using this comma. After splitting, let's come to the next line and we will say map. We will say simple granted authority, which is a class, and we will add new at the end, and dot to list. See, and we are returning this list. So what we are doing here, we are getting the value of the roles string from this user. We are splitting the string using the commas, so just in case you decide to add multiple roles to this user, and then we are mapping through that new splitted string and creating new simple granted authorities using the string value that we get from our map call. Finally, once we have multiple or a single simple granted authority instance, we are adding them to a list and returning that list from this method. So since lists are part of collections, this checks out. Now, if you are confused about this method, I would suggest that you do some more study on how Spring Security works and how you can implement multiple roles for users. So that's a bit out of the scope of this course. So this is what we have to do now. Next up, let's go inside isAccount non-expired. We want to return true here. Then isAccount non-locked, yes, we want to return true. Is-credentials non-expired, true. And also, is the account enabled? Yes, true. So that's it. We have successfully implemented the user details interface, but other than these three, we also need an ID and we need a private string name for the user. Now, like the other models, this ID is going to be an ID and it is going to be a generated value. And we will need a getter and setter for our name. So let's come at the end of all these overrides, or maybe here. Let's come to this place and we'll say alt insert. We will generate a getter for our ID. No, I mean our name. We will also need a setter for our name. There you go. Now, in the case of this user model, we will actually use our ID field. So we will also add a getter for that. And since we are going to create new users, we will also need setters for our username and password and roles. So let's scroll down and come to get password, and I will come after it and insert a setter for our password. There we have it. Next, after the get username, I will insert a setter for our username. And finally, we do not have a get roles method, but we have this one, so I will just come after this and I will put a setter for our roles. There you go. Okay, looks like the model is ready to be used. And you know what, let's just generate a getter for our roles as well, because even though we have this get authorities method, we may also need a plain old getter for our roles string. So let's just add the getter, and it looks like everything has been set up finally. I would just like to check the generate menu once again to see if we have anything left. Yeah, we have left the ID setter, but we are not going to need that. So once you are done with that, let's just close this, and we will now create a new package called config. Next up, let's create a new repository. So I will right click on the repositories package, create a new Java class. It has to be an interface, and name it user repository. Like the other repositories, I want to extend Neo4j repository, and that's all we need for now. We will come back to this because we will add 2 more custom queries to this repository, but those are not needed at the moment. Finally, we will go inside service, and we are going to create an special service for our authentication system. So we will create a new class called Neo User Details Service. You may call it something else like Neo4j User Details Service. The thing is, this is going to be an user detail service that we will in turn use with Spring Security. So we have this class, and it's going to implement another interface called User Details Service. And just like the model, we will implement the methods. There is only one method, load user by username, and that's pretty much it. So as you can say from the name of this method, this can return a user using its username. So for that, we will go back to our user repository. We will create a method that returns an optional user, and we will call it find user. Sorry, I have made a mistake. We will have to tell it the name of the model as well as the type of ID we are using. All right, now we can say find user by username. We will receive the username as a string. This is very simple method, and that's all we need. Now inside our Neo user details service, I will explain why we need this class in a bit, but for now, just write the class along with me. So I will create a private final user repository, then I will have a constructor. There you go. And then as you can see, this method here returns the type user details. This is one of the interfaces that comes with the Spring Security framework. So instead of returning null, what we are going to do is return user repository dot, or let's come to the next line, find user by username. We'll pass the username that we have here, and then on the third line we will say or else throw, and inside the method we will create a new lambda, new username not found exception, and we will pass a message username not found. Then can just add the username to the message. Yeah, so that's what we have. So as you can see, the user details service interface implements a method called load user by username. So what we are doing here, we are using our repository instance and we are calling the find user by username method. Now it returns an optional user. So if we have the user, then we will return it, and if we do not have the user, then we will throw a new username not found exception. And we have to throw this exception because by the definition of this interface, this method has to throw a username not found exception in cases where the username is not found. So that's all we need here. Now finally, we are going to write the big chunk of authentication code that we will need to use our database instead of some preset user. So go inside project, I will collapse everything, then go inside source main Java. And as you can see, I have a package called config. So I will right click and create a new class called security config. By the way, the service class that we created has to be annotated with the service annotation. Yeah, so all the service classes have been annotated. Okay, so inside the security config class, we have to annotate it with configuration, then enable web security. Okay, then inside the class, we will create a private final Neo user details service. We will have a constructor, and then we are going to create a bean, and that bean is of type security filter chain, new security filter chain. It will receive HTTP security. This one, we will call it HTTP security, and this throws an exception. Okay, let's annotate with the bean annotation so that Neo4j will handle the task of instantiating this class and everything. Now inside this method, we will create a new security filter chain. Once we have finished working on it, you will understand what it actually does. So we'll say return HTTP security, this one, then dot session management. Inside we'll say session, create a new lambda, session dot session creation policy, then session creation policy dot stateless, because since we are creating an API, the authentication has to be stateless. Then we are going to disable CSRF protection because we don't need that. For that, we will use abstract HTTP configurer. Yes, this one, and disable. Okay, then on the next line, we will say course because we are going to customize our course. Customizer dot with defaults. So course will be configured with the default settings. Finally, we'll say authorize HTTP requests. Inside we'll say auth and auth dot, it will say request matchers. Yes, and inside the request matchers we will say API slash v1 slash auth slash me. Okay, Let's leave it to that for now. We will add more routes to it later. So I'll say dot authenticated and dot any request dot permit all. Finally, we will finish this by saying user details service, neo user details service dot http basic customizer dot with defaults and dot build. That's a lot of code, right? So let us take a look and try to understand what's happening here. So by default, the Spring Security Framework uses a security filter chain that blocks any request to your server. You will have to authenticate for every single request to the server, and we do not want that. Also, in the default security filter chain, it uses your application.properties file or a randomly generated user as an authenticatable user. We also do not want that. We want to use the users in our database. So for that, we will need to create a new security filter chain that will essentially define how we want to secure our application. So inside this bean, I hope you understand what beans are. Beans are just Java classes that are managed by the Spring Boot framework. So we are creating a new bean that is of type security filter chain, and it throws an exception. Okay, so inside this bean, we are saying return HTTP security, which is of type HTTP security. This is one of the classes that comes with the Spring Security Framework. And the first thing that we are doing is we are making the session stateless. I know this is a long line, but all this does is it makes the sessions stateless. So we do not hold any session data whatsoever. Then we are disabling the CSRF securities because since it is an API and we essentially do not have any web interfaces within this particular application or service, we can successfully disable the CSRF protection. Then we are configuring CORS. So in an application where there is no Spring Boot security framework, you have to customize your CORS settings somewhere else. But since we are using Spring Boot security, this framework is going to intercept the request first, and then it will pass it to the application or other configurers. So we have to configure the CORS right in the security filter chain configuration thing. So right now we are customizing the CORS settings with the default ones, but we are going to change it very soon. Then we are saying authorize HTTP request. So this is the method where we will define which routes has to be protected by our application and which routes do not need to be protected. So inside we have an auth object, and we are using the request matchers method to say that, hey, Spring Boot security, you have to protect any request to this particular endpoint. We haven't created this endpoint yet, and you only need to stop any request coming to this endpoint, and all the other requests, any requests, just permit them to connect. So when we get a request in this particular endpoint, it needs to be authenticated. Any other request should be permitted. Now, next up, we will actually configure our CORS configurations. So we will say CORS configurer or CORS configuration source. Yes, this one, we want this one. And then we will say CORS configuration source. We will start the method and we'll annotate with a bean. Now inside this bean, we will say CORS configurations equals to new course configuration. So we are creating a new course configuration. Then we are going to change things in this configuration. So we will say course configuration dot set allowed origins. So which origins are we allowing? So I will just say array. Let's check what it takes. So it looks like it takes a list of strings. So I will say array dot as list, arrays dot as list, and I will create a string http localhost 3000, and also just in case http 127.0.0.1, which is localhost as well, 3000. So I have been made aware by Gavin Long that the React application that he will be working on will run on localhost 3000 or 127.0.0.1 port 3000. So what I have done, I have allowed these two origins to connect to my application. Now this is one way of doing things. To be honest, these two values, these should be resided inside our .env file, but I am not going to do that since I have shown you how to use a .env file. I will just add a to-do here which says make sure that the origin list comes from an environment file. So I would suggest that the viewers or you essentially take this as a challenge and implement this part using an env file. Put your code on GitHub and share the link in the comment section. I will take my time to go through every single code shared in the comment section, and I will make sure that everything is right. So this is one of the challenges. I will add that as a to-do, and you can actually click on this button here to do, and you can see what challenges I have set. So that's one challenge. Then the second one is course configuration dot set allowed methods. And what methods are we allowing? Arrays dot as list. This also takes a list, so this is how we are going to do get, and we will do post, we will do patch, then put, delete, options, and hit. These are all allowed methods. Then we'll say course configuration dot set allow credentials. Yes, this one, and we'll set true. Nice. Then we will say course configuration dot set allowed headers, and arrays dot as list authorization request type content type. So these are the three headers that we want to allow. Finally, we'll say configuration dot set exposed headers, and it will be called arrays dot as list. Inside here we will say x get header, and lastly we will have course configuration dot set max age. We will, let's do it 3600L, so L for long. Next, let's just create an URL based course configuration source. So we'll say URL based course configuration source, and URL based course configuration source equals to new URL based course configuration source. Yeah, try saying that 10 times faster, right? URL based course configuration source. Yeah, I can do that. And we will say URL based course configuration source. Yes. Dot register course configuration. And we want to apply this configuration to all the routes in our application. So that's what this pattern means. So this is the root and anything that comes after that. Then we'll say comma and course configuration. Yeah, nice. Finally, we have to return our URL based course configuration source. Okay, so now we have our course configured. One last thing that we have to configure is actually a password encoder. So I believe you remember when I showed you our database architecture that we are saving the password for the users as bcrypt encrypted hashes. We are not saving plain text passwords because you should never do that. So we will need to let Spring Boot security know what encoder we are using. So to do that, I will say password encoder. This is another bean. I will annotate this one with bean. And then inside the method, I will say return new bcrypt password encoder and end it there. So yes, we have done most of the things. Oh, by the way, I think I have missed these 3 lines. So what we are saying here is we need to let the security filter chain know which user details service are we going to use. And in our case, we have a custom user details service, which is the Neo user details service. And what we have inside this class, we have implemented a single method that helps us to use or look for the user. So every time some user tries to log into our application, the Spring Security filter chain will use this details service, look for the user, and then check the password against the hash that we have saved in our database using this password encoder. And if it matches, it will let the request pass through. And if it doesn't, it will throw a username not found exception. So finally, we are going to use an HTTP basic authentication. I know this is pretty insecure, but for the scope of this project or this application, this is totally fine. I could have implemented a more sophisticated JWT based authentication, but that will take a lot more time and a lot more code. So I want to focus more on the Neo4j and Spring Boot connectivity rather than the authentication and security part of the application. So this is what we are going for. So now that we have configured our security thing, let's just go ahead and create this endpoint. So we will go to project and we will create a new controller, and it will be called user controller. Let's annotate this one as a REST controller and request mapping to API /v1/auth. Inside we will have a single method for now, which will be public logged in user, and we will create an endpoint which will be a get mapping, and it will be called me. Finally, inside this logged in user, we have to define our return type, which will be string for now. And we will get something called the principal. I will explain what principal is, and we will say return principal dot get name. So okay, let's make sure that this endpoint is right. So let's go back to our config, API v1 auth me. So everything checks out. Okay, then let's start our application and try to log in using one of the users in our database. Right now, we are inside our Neo4j dashboard and we can see all the users in our database. So I'm going to just select John Price and the username is just Price. Now the password for all these users such as Mirza Mikhail or Macmillan, the password is actually password. I have already encoded the password using bcrypt and saved the hash. So I will just copy the username of John Price, and let's go back to our Insomnia. Then right now, if I make a request without any authentication, it should work because the single course and get all courses endpoints have not been protected. I hope that you remember that the only endpoint that is protected right now is the me endpoint. So I'll create a new HTTP request. I will call this me HTTP localhost 8080 API slash v1 slash auth slash me. And if I send a request, as you can see, I'm getting 401 unauthorized. But if I go inside auth, select basic auth, and as the username, I will say price. And for password, I will say password. Let's see if it works or not. So as you can see, this time we are getting 200. So what's happening here? Let's go back to our code and let me explain it to you. Now, right now we have a single endpoint called /API v1 auth me, and according to our security configuration, this is one of the protected route and we have to be authenticated to hit this route. So inside this method, we are getting a principal object, and this principal object usually contains information about what user is authenticated right now. So once you send in your username and password, our security config will intercept that and pass that to the user details service. The user details service in turn will look for an user using the username that we have got from the user, and if it finds the username, it will give it back. Otherwise, it will throw a username not found exception. Once the filter chain has found an user, it will get the password from that user and check its hash against the password submitted by the user using this password encoder. And you may ask, how does the filter chain gets the password? Well, if I go back to models user, and you will see we have a getter for the password, get password, and this is a part of the user details interface. So that's how it gets the password hash. And if the user is giving the right username and password, he will pass, otherwise he will not pass. So that's how this entire authentication system works. And if you have done anything right, you should be able to authenticate new users to your application. Now that we have our user, we can finally begin working on the enrollment part. So every user can actually look at our courses and enroll in the ones that they like. So that's what we are going to do now. Now that our users can log into our system, we want to create a way for them to register in our system. So we have a way to log in. Now we need a way to register. So before we start writing the code for registering the user, I would like to create a few packages and classes. Now the first one is a package called requests. And inside here, I will create a new Java class called create user request. Now I will explain what it will do, but just follow along for now. Then inside this class, we will say private string name, private string username, private string password, private string roles. So everything that the user model has except the ID field. Next up, we will create a constructor, and this time we will pick all of them. And after that, I will just create some getters and setters. Okay, the request class is ready. Let's close that. Next, what we need is a user DTO object. So user DTO. And this one is going to be really simple. Private string name, private string username, private string roles. We do not want to return the password in our responses, so we will just leave that out. Next, we want to create the constructor and the getters and setters. There you go. We have a user DTO now. Next, we need to create a service called user service. User service. And this one has to be annotated as a new service for sure. Then we will need a private user repository. Let's make it final. And then we will have private final password encoder, because we want to encode our user's password. Then I will have my constructor and a function, public, and this is going to return a user, create user, and this will take a create user request, not any request, but create user request, and create a new user. So I will say user equals to new user. Then I will say user dot set name request dot get name. And I hope you remembered that we just implemented this get name method inside the create user class. So that's why we can use that. Then user dot set username request dot get username. Nice. User dot set roles request dot get roles. User dot set password, and this is where the encoder will come in, and I will say password encoder dot encode. Inside there I will say request dot get password. So this will take what the password is that we got from the user, and then encode it and set it as the user's password. Finally, we will say user repository dot save user. The save method comes with all the repositories, and we will return the user. That's it. We have our service method ready to go. Let's go to the controller now. And here I will say public and then response entity of type user DTO sign up, and this will take a request body and map that to create user request. We'll call it request. And let's go inside the method, and I will say, I will also need a reference to our private final user service, and I will need my constructor. Then I can say user service dot create user, and I can just pass the request to it, and it returns a user. Then I will create a user DTO response user equals to new user DTO. Now first I need the name, so user dot get name, then user dot get username, and user dot get roles. Yeah, that's all I need. Then I can just return a new response entity, and the body will be the response user, and the status will be created because we have just created a new user. So yeah, that's all we need to sign up a new user, and this is really easy to do. I will have to create a post mapping for register. Yeah, that's all we need. Now we can go back to Insomnia and check if this works. So I'll just start my application. Then I will switch to Insomnia and I will create a new request called register. Okay, this will have a body. First, we need a name. So I will do Farhan Hasin Chaudhary, comma, I will need an username, Farhan. Then I will need a password, and I will need a roles string. So it will be role user. Make sure you are writing the role like this. And then I'll send the request to http localhost API slash v1 slash auth slash register. That's it, I believe. Okay, let's change it to post. And we do not need any authentication for this, and let's hit send. So looks like a new user has been registered. It says 201 and the username is Farhan. Now there are two ways to verify if the registration has gone through correctly or not. First, I can go to my me request. I can go to basic, and instead of price, I can say Farhan and the password is password. I'll say send. And it looks like it gives me back Farhan, which means the user has been registered to database. But still, if we quickly switch to our database dashboard, then click on user once again, it got me back all the users, and as you can see, Farhan Hasin Chaudhary is right here. But right now, Farhan or me, I am not enrolled in any of the courses. So next we are going to work with the enrollment process, and we are going to make sure that all the users can actually enroll in a class. But before that, I would like to give another challenge for you. So if I go back to the user service, as you can see right now, I am not checking if this username has been already registered or not. So I will leave it to you so that you can figure out how to check if a thing exists on the database using Spring Boot data or Spring Data repositories and make a decision on that. So I will add another to do, and I will say make sure that this username does exist. And let's just cut that from here, and I'll put that over the username. So this is another to-do that I'm leaving out for you. I will look forward to any submission in the comment section, and I will actually let you know if anything is wrong with the code. So let's close that. and start working on our enrollment process. Now, before I write anything in my services or in my controllers, I would like to make sure that we have all the necessary queries in our repositories. For example, in order to enroll a user in a new course, we will have to create a new relationship between the user and the course. So like I showed you before, you can actually do that through the models. But in this case, I am going to create a custom query that will have a custom query result. And you can use that to create a new enrollment relationship. So for that, I will go to my repositories and then user repositories. And I will write two methods here. The first one is going to be a boolean, and it will be called find enrollment status. So you can use this method to check whether a user is already enrolled in a course or not. And I'll take a string username, and I will also take a string identifier, which is the course identifier in our case. So we are going to write a custom query just like we did before, and it will go something like match user. Oh, this has to be a string, of course, comma, there will be a course, and then where user.username equals $username. So this variable right here, and course.identifier equals $identifier right here, this variable. So what we are doing is we are querying for a user that has the same username as we have passed to this method, and then we are looking for a course that has the same identifier as we have passed in this method, and we are saving the user in a variable called user and the course in a variable called course. Next, we want to give a space and then enter so that we can begin on the next line. And then we'll say return exists. We will say user enrolled in course. Yeah, that's pretty much it. So what we are doing is we are looking for a user and course against the username and identifier that we have, and then we are checking if there is any outgoing relationship from the user with the course of type enrolled in. So I believe you remember that back when we are designing our database, we had a relationship called enrolled in, and it was an outgoing relationship from the point of view of the user and an incoming relationship from the point of view of the course. So there we go. We can use this method to check whether a user is already enrolled in a course. Next up, we want to create a query that we can use to create a new enrollment. Now, before we do that, we need another class. So we will create a new package, query results, and inside that we will create a new class called course enrollment query request or query result. Query result. Now this is a very simple class. We will say private user private course, and we need to import these classes, obviously. Yes. Okay, we have both the classes. Then we will have an empty constructor like that. and we will have some getters and setters. So alt insert getter and setter, both of these. So there you go, we have a course enrollment query result object. Now if I come back and I create a new method, and this is going to return a course enrollment query result, I will call it create enrollment relationship. Basically, you want to be explicit with your names, and I will need a username. Also, I will need an identifier. Now, the first bit of this query is identical to this one. So what I am going to do is I will copy this entire match part, come inside this method. I will say query, put it in space, and then enter. Now on the next line, I would like to say create user. In fact, you can just copy this part here. So we are going to create a new outgoing relationship from the user to the course of type enrolled in. Then finally, we'd like to return the user and the course. Now, as you can see, this query returns a really complex data. It returns an user object and it also returns a course object. So like other custom queries like this one, we cannot just say that this returns a Boolean type. Instead, we had to create our own custom class that has an user object and a course object and use that as the result of this query. So this is how you can map complex queries to custom made classes. Okay, so our user repository is now ready to go. I believe we can enroll our users to classes now. But we cannot just put the code for course enrollment inside the user service or user controller or the course controller at all. Instead, what we are going to do is we will create a new service called course enrollment service, and it will be a class, a service class. Then inside there, we will have a few methods. Now the first method that we have, but before that, we will need a private final course repository and private final user repository. Now this service can access both repositories because we are going to work with both courses and enrollment. But if we had to put this code inside the course service, then we would need to unnecessarily refer to the user repository inside the course service. That doesn't feel good at all. That's why we have a separate service for creating the enrollments. So inside we will have a constructor and we will have a few methods. Now the first method would be public boolean get enrollment status, and for that we will need a username and a course identifier. Then inside the method we will just say return course repository dot check user repository dot find enrollment status, and we will pass it the username and the course identifier. So this way we can use this method to check if a given username is enrolled in a course or not. Now the next thing we need is public, and this is going to return a course enrollment query result, and it will be called enroll in, and it will also need a username and a course identifier. Okay, we will return user repository dot create enrollment relationship, username and identifier. Okay, so yeah, we are done with these two methods. We will need one last method, that is we need public list of courses, and we will call it get all enrolled course by username, string username and string identifier. Okay, so what this method is going to do is, if we give it a username, it will give us back the list of courses the user is enrolled in. And I just realized we really do not need the identifier here. Now we do not have a repository method for this, so let's go to our course repository and create a new method. This will return a list of courses, and we will call it find all enrolled courses by username, and we receive a string username, and then we can say query match. We are trying to match a user where the username is username. So this is another way of doing a where query or where clause. So we will have a user with the same username that has been passed to this method. Then once we have that node, we want to get enrolled in course. So we want to get all the courses that has an outgoing relationship with this user of type enrolled in, and I'm saving all those courses in the courses variable, and I'll just return courses. And we will also import the list method, java.util, of course. And yeah, that's it. So let's go back here and we will say return course repository dot find all enrolled course by username, and we'll just pass the username. So that's it. We have our course enrollment service ready to go. We can use it to enroll our users in a new course. We can get the enrollment status of a user, and we can also get all the enrolled courses by username. And I just realized it should be courses and not just course. So there we go. Okay, now I think we are ready to create a new controller. The controller will be named course enrollment controller. Like the other ones, it's going to be a REST controller for sure. Okay, let's just go back to our service class for a bit, course enrollment service, and yeah, we have annotated it. Yeah, and we will do a request mapping API / v1 / enrollments. Now this enrollments endpoint, these need to be protected, because if you go back to our service, for example course enrollment service, you can see all these methods needs to know the username of the currently authenticated user. So for that we need to protect this route. So we will leave the controller open and get back to config and security config. Let's close this and come to the request matchers part. I will put a comma and I will say API / v1 /enrollments /, which means anything that comes after API /v1 /enrollment / anything should be authenticated or protected. Let's close that. And inside our controller class, we will need a few services. So I will say private final course enrollment service, and we will also need private final lesson service, because we will need to know what lessons are part of a certain course. Now I will have my constructor, and we can start working on the endpoints. Now the first one I want to do is I want to let the user enroll in a course. So for that I will say public response entity of type course enrollment DTO, and we need to create this class, create class course enrollment DTO, and we want to put it inside the objects package. Here we have our DTO. We need string private string username, so the user name of the user that has just enrolled in the course, private string name of the user, private course, and the course that the user just enrolled in. Then we will have a constructor, and we will have the getters and setters. Yeah, that's pretty much it. So we want to return a course enrollment DTO, and we will call our method enroll in. Now what we are going to take, we are going to take the request body, and we will create another request called course enrollment request. Let's hover over it and create type parameter course enrollment request. You know what, let's just copy the name, go to project, go to requests, create a new class called course enrollment request. And inside this we need private string identifier. This is the course identifier, of course, and we will generate a constructor and the getters and setters. Okay, let's go back to our code, request body course enrollment request. So we will have our course enrollment request, comma. Another thing that we need is the principal. Sorry, I forgot to name this. So I will get the principal, because this is how you get the username of the authenticated user. Now inside this method, we will say course enrollment query result. Let's call it enrollment query result, yes, equals, we will say course enrollment service dot enroll in. What is the username? The principal dot get name. And what is the identifier? Request dot get identifier. There you go. We have a new enrollment request query, right? Query result. Now we cannot just return this query result verbatim, rather we will need a new DTO called course enrollment DTO. Now I will hover over it. Some more action. Okay, let's again just copy this, go to project, go inside objects. Oh, it looks like we have a course enrollment DTO create. I just forgot about this. So what I will do is course enrollment DTO. We have that. Yeah, I just forgot that we created this. So response enrollment equals new. The first thing that we need to pass is the username. So we will say enrollment query result dot get user dot get username, because our query result has a get user method that in turn returns a get username method, and we can use that to get the name of the user or the username of the user. Next up, we have the name of the user. So enrollment query result dot get user once again dot get name. And you know what, this line is getting too big, so I will just put it in the next line, comma. Let's bring it down here. Yeah, much better. Enrollment query request dot get course. That's pretty much it. All we need, the username, name, and the course. Finally, we can say return new response entity. The body will be the response enrollment, and the HTTP status should be okay, but it really depends upon you. Since we have created a new relationship, you could have also returned created here, but I'm going to just return okay. Now this is going to be a post mapping. Let's try and enroll our user in a course. Okay, let's check our request once again. We just need an identifier, so that's what we are going to do. I will go back to my Insomnia client. I will create a new request called enroll. This is going to be HTTP localhost 8080 /API/v1/enrollments. And inside, this has to be a post request, by the way, and inside the body we need an identifier. So let's go inside get single course, this one, go back to enroll, and we'll put it here. Let's click on send. So yeah, I just remembered I didn't restart my code. So let's go back to IDEA and do that. And I will send. Nice, we are getting a 401 unauthorized response because we are not authenticating any user. So I will go to basic auth. I will add Farhan and password is password. Let's send the request. So it looks like that we should leave the course enrollment request as an empty constructor instead of taking the identifier as one of its parameters, because if we do that, the request may not work. So I'm keeping it empty. And now when I try to create a enrollment from Insomnia, it just works. As you can see, Farhan has been enrolled in Blazor shopping cart application course. So to verify, we can quickly go to our RDB dashboard, and if we click on enrolled in, we should see that Farhan Hasin Chaudhary is now enrolled in the Blazor shopping cart course. Now, other than verifying from the database itself, we also want a way to get the list of all the courses a user has been enrolled in. So we have already created a service method for that. So let's just go back to our controller and implement that. So here inside our controller, we will create a new getMapping method. So public response entity, this is going to be a list of the course TTO, and we will call it Enrolments. We will take the principal because we need the username. And inside this method, we will say list course to courses equals course enrollment service dot get all enrolled course by username, and we will say principal dot get name. Now we have a list of courses that the user has been enrolled in. On the next line, we will say, just like before, a list of course DTO and response courses equals courses dot stream dot map. Inside the map method, we will say course, this is a lambda, course DTO response course equals new course DTO, and we need an identifier, title, and teacher name. So I will say course dot get identifier, course dot get title, and course dot get teacher. And then I can just return response course. And finally, after this curly brace and the last parenthesis, I will say collectors.toList. So this is just like we did before with the courses list. So I'm not going to again explain this. And I will say return new response entity, response courses, comma, http status dot OK. All right, this is a get mapping, of course. There you go. Let's restart our application. Go back to Insomnia, make a copy of the enroll request and call it Enrolments. Turn it into a get request, get rid of the identifier, make sure that we are authenticating, and let's hit send. Okay, so looks like we have a list of the courses that this user has been enrolled in. What we need is we need the list of lessons too. So let's go back to our controller. I'm going to steal some code from the course controller class. I hope you remember inside this one, we actually made use of the lesson service. So I'll copy this line. I'll go back to course enrollment controller. And put it down here. Course enrollment.set lesson. And then return the response course. We will rerun the application. We'll go back to Insomnia, resend our request. And this time we are actually getting the list of all the lessons as well. Now that's pretty much it. We have done a lot with our applications, except I want to implement one last thing in our code. So you may remember that we have implemented the code necessary for a service and repository method that returns a Boolean based on whether an user is enrolled in a course or not. So in our list of courses, I would like to add a new Boolean variable here that says enrolled in, and that will return true if the user is enrolled in a course and false in case he or she is not enrolled in a course. So let's go back to our code. What we can do is we will go back to our course DTO, and inside we want to add a new Boolean. So private Boolean, let's use the primitive type, and is enrolled. That's it. Now we will need a getter and setter for this one. Yes, we got that. Now let's go back to course enrollment controller, and we will say response course dot set enrolled, and we are going to hard code it to true. Since the user just enrolled in this course, we know for sure that this is going to be true, so we will not make another database request and just write it as true. But inside our course controller, we will actually have to do a database call. For that, we will take the principal and we will add a check here. We will say if principal is not null, then response course dot set enrolled. Inside we will say we'll need another service, private final course enrollment service, and we will say course enrollment service. Yes, got that. It's a lot of boilerplate, to be honest. Course enrollment service, yeah. So inside set enrolled, we will say course enrollment service dot get enrollment status and principal dot get name and course dot get identifier. So we are checking whether the user has enrolled in the course or not. Now, why we are checking for principal is null or not? I hope you remember that in our course index, anyone can see the list of our courses because it's an open directory. So in case we do not get any principal or authenticated user, we will just set it to false, set enrolled. And if we get a principal, we will set it to whatever the database returns. So I will rerun the application and show you how it works. Let's quickly switch to Insomnia and get all courses. So as you can see, it says enrolled false in all of these because I am not logged in. But if I log into my account, Farhan password, and hit send, you will see that it says true on the Blazor shopping cart application and false in all of the other ones. Now, while we are here, I thought I will make one little adjustment to our code. That is, in enroll, we are sending something called an identifier. Now, this is not clear. I think what would be better if we could call it course identifier. This is a lot better, I think. So I will go back to my code, go inside the course enrollment request, right click on the identifier and go inside refactor, rename. So instead of identifier, I would like to call it course identifier. I'll hit enter. Yeah, these are all the references. Get course identifier, course identifier. Yes, we are going to. Let's make sure that these are right. Yeah, let's hit OK. Let's rerun our application and see everything works fine or not. Okay, it looks fine. So that's pretty much it. We have successfully implemented the ability to enroll in a new course. The user can get the list of enrollments. The user can register, the user can sign in and see the lessons in the course. Now, on the next part of this course, Gavin Long will walk you through the entire process of creating a React app based on this API. He will show how you can use the identifiers to get the corresponding YouTube videos and how you can basically create a course management system frontend for yourself powered by my API. Now, one last challenge that I would like to leave for the user is inside the services and course enrollment service. Before we enroll our user in a course, we need to make sure that the user has not been enrolled in the course already. So this is something that we have to make sure. Right now, if you try to enroll the same user twice in a course, you will create two relationships to the same course. So you will get double results. So what you should do is you should check whether the user has already been enrolled in the course using the get enrollment status. Maybe, I don't know, I'm giving a hint. And then you should enroll the user in the course or return something else. Now, this is another challenge that I'm leaving up to you. So if you go inside to do, you will get 3 to-dos, and 1 is in the config and 2 is in the services. So make sure that you are completing your challenges. It will give you a lot more confidence, to be honest, and you will learn a lot from your researches. Make sure that you leave the link to your repository in the comment section below. I will come there, I will check the course submissions, and I think it would be a nice conversation between us. So I hope that throughout this entire course or this part of the course, you have learned something about the Neo4j database, which truly is an amazing technology. You have learned how to create an API powered by Neo4j on Spring Boot, and a few other things here and there on how to structure your application, how to use an IDE and things like that. So if you ever need any help, just give me a shout out in the comment section. I would love to help. And best of luck for the rest of the course. Gavin Long is an amazing instructor, and I can say for sure that you will have a great time. So until the next time, take care and be careful. Bye.
Before we get started with coding this React application, I need to let you know that I've had to make a few assumptions regarding the knowledge and experience of the viewers of this part of the course. So ideally, the viewer of this part of the course should have at least a basic knowledge of React, JavaScript, HTML, and CSS. So let's start with the very basics. We of course need a code editor for writing our React code. I will be using Visual Studio Code for Windows for this purpose. You can download Visual Studio Code for Windows from this URL. In order to run our code locally, we need to install Node.js. You can install Node.js from this URL. Node.js is an open-source cross-platform JavaScript runtime environment. We need a local working directory to house our application's code. So please create a working folder in a location of your choosing on your computer. And let's give our working folder a sensible name. My working folder for this project is Curriculum MNGT Management Client. So, Curriculum MNGT Client. Then let's open the working directory for our project within Visual Studio Code. Note, we can check what version of Node we have installed while we're in Visual Studio Code. We can do this by first launching the terminal window. Launch the terminal window by pressing Ctrl and the tilde character. Then at the command prompt, type node-v and press Enter. Great, and we can see what version of Node we have installed on our computers. An easy way to set up a React project is to use the create-react-app command. We can use this command to generate the infrastructure for our React application. When I say infrastructure, I mean the node modules that are necessary for harnessing foundational React functionality is generated through the use of the create-react-app command. There are other ways, perhaps better ways, of creating the foundations for a React project, like for example using a technology named Vite for this purpose. If you are interested, please read more about Vite at this location. Using the create-react-app command provides a simple way to create a React project, so I'm going to use the create-react-app command for this purpose. At the command prompt, type npx create-react-app followed by a sensible name for your React application. I'm going to name my React application Curriculum-MNGT. MNGT, of course, stands for management. Then let's press the Enter key. This process may take a while, so this will give you an opportunity to contemplate life, the universe. Okay, you don't have to do that, but you may want to get yourself a cup of tea or something like that while you wait. Okay, great. And you can see that the foundation for our React project has been generated. The Node Modules directory has been created, which contains all the React dependencies and packages needed to build and run a React project. As you can see, a new root directory for our project has been generated that is of the name that we gave our application when we ran the create-react-app command. So for better clarity, let's open another instance of Visual Studio Code where the newly created project directory is the root directory within Visual Studio Code. To do this, let's make sure the terminal window is launched. Remember, you can do this by pressing the Control key and the tilde key. Then at the command prompt, make sure the current project's working directory is the current directory at the command prompt. Then type cd space and then the root directory of the React project. Then press the Enter key. Now at the command prompt, type code, followed by a space, and then the period character. Then press the Enter key. This will result in a new instance of Visual Studio Code being presented. And now the React project folder is the root directory. Now let's close the previously launched instance of Visual Studio Code. The create-react-app command has generated the infrastructure for our React project, but has also generated a few files that we don't need. So let's delete the following files that we don't need: reportwebvitals.js, setuptests.js, and app.test.js. We must also delete the ESLint config setting from the package.json file here. Let's save our changes. Then lastly, let's open the index.js file and delete the code regarding report web vitals. Great. So we are now ready to develop our React application. So at the moment, we have very basic functionality that has been generated for us by default through the use of the create-react-app command. So let's ensure that we start off on a good footing, as it were. This lets us know that all is working as it should be before we start developing our application. So to launch the React app in our default browsers, we can type npm space start at the command prompt and press the enter key. Great, and we can see the React logo spinning, which means we are good to go. So let's start creating the code for our application. Within the src directory, where the source code will reside, let's create a subdirectory named components. As you have probably guessed, we are going to create our React components within the components directory. Let's also create a directory within the src directory named images. Please download this image from this location on GitHub and ensure that this image file resides within the images directory. We are going to use this image as our hero image on our home page. So this image will be referenced from within the home component. The first React component we are going to create is the home component. This component denotes the page that will first be displayed when our application is first launched. So let's create a directory within the components folder named home. The first letter of this folder name should be in lowercase. Within the home folder, let's create a file named home.js. The first letter of this file should be in uppercase. So we can use a shortcut to generate boilerplate code for our home component. To do this, type RAFCE, like this within the code editor, and press the enter key. Note that in order to utilize the RAFCE shortcut, you must first install the appropriate React snippets extension, if this extension is currently not installed. This installation can easily be done through the Extensions tab within Visual Studio Code. At the top of the home.js file, let's import the hero image from within the images directory, like this. Let's include an image tag within the JSX code returned from the home component. Then let's open the app.js file. Let's import the home component into the app component with this line of code. Let's delete the code that we don't need, but ensure that we leave the div root element that contains the class name attribute that references the app.css class. Then let's appropriately reference the home element by including the home tag within the div parent tag like this. Let's type npm start to fire up our application. Great, but the image looks huge and is not displayed appropriately for our hero image. So we are going to use Bootstrap to style this hero image. So to install Bootstrap, type this command at your command prompt and press enter. To have access throughout our application to relevant Bootstrap classes, we must include this import statement within the index.js file. Now within the root div tag of the home component, let's include the class name attribute and set it to the Bootstrap class named container, like this. Let's run our code. What's happening here is the image is still too large for its container element. So to remedy this, let's create a scoped CSS Styles sheet for the home component. So let's create a file within the home directory named home.css. Within the home.css file, let's create a reference to the relevant image within the container div tag like this, and let's set the image width to 100%. Within the home component, let's create a reference to the home.css file with this line of code. Let's type npm start at the terminal prompt to launch our application. And that is much better. Great. So that is a great start, but we are also going to need some other third-party packages, dependencies, in order to integrate certain functionality into our application. For example, we want to install the React Router DOM package that will be instrumental in the global management of our menu and link functionality, our navigation functionality. We are going to use the React Player component for displaying videos that denote lessons for our courses to our users. We'll use Axios to manage our client interactions with the server-side Web API component. So here we have used Bootstrap's container class to house our hero image so that it is appropriately displayed within our home component as a hero image. We can also leverage Bootstrap by using components that reside within the React Bootstrap package. We'll look at using such components a bit later in this video. For now, let's install React Bootstrap. To install React Bootstrap, type npm -i -react-bootstrap and press the Enter key. Great. Let's install the Axios library. We are going to use Axios for making our HTTP client requests to the relevant server-side endpoints, so as to return the relevant data from the Neo4j database that hosts the relevant curriculum data that we want to display to our users. We'll also use Axios to implement the Enroll functionality, i.e. this is functionality whereby a user can enroll in a particular course. We could use the windows.fetch function, which is available by default within our browsers for this purpose, instead of Axios, but Axios provides us with key advantages. Please navigate to this URL if you'd like to learn more about these key advantages. This link is available below in the description of this video. To install Axios, type npm -install -Axios and then press the Enter key. The next packages I would like to install allow us to leverage Font Awesome from within our React applications. So at the command prompt, please type npm -i @FontAwesome /React-FontAwesome and then press the Enter key. Let's install one more Font Awesome related package. To do this, type npm -i @FontAwesome /free-solid-svg-icons and then press the Enter key. Great! We'll look at the details of using the relevant Font-Awesome functionality a little bit later in this video. The next component I want to install is React Player. This will allow us to play YouTube videos from within our React application. The individual lessons within the courses in which our user is enrolled will be presented to the user as videos. These videos reside on the YouTube platform. So to install React Player, type npm -i -react-player at the command prompt and then press the Enter key. Then let's install React Router DOM, which allows us to leverage rich navigation and routing functionality from within our React application. To install React Router DOM, at your command prompt, please type npm -i -react-router DOM and then press the Enter key. If we open the package.json file, you can see the relevant dependencies that we have just installed. Great. So let's create the navigation bar that will appear at the top of our application's UI. So this can be referred to as the header for our application. The navigation bar will contain a register and login button and relevant navigation menu options. So let's create a folder within the components directory named header. Please ensure that the H in header used to name our folder is in lowercase. Let's create the file for the header component and let's name it header.js, where the H is an uppercase. So we are going to use Font Awesome in this component to display a graduation cap as the logo for our application, which will appear in the top left-hand corner of the user's screen. So let's write code to import the relevant Font Awesome components. Then we are going to use React Bootstrap for our buttons, so let's import the button component from the React Bootstrap package with this line of code. We are going to use the container component for layout purposes. Let's import the nav component from React Bootstrap, which will be used for layout and styling purposes. Let's also import the navbar component for the purpose of styling our navigation display. Lastly, let's import the useNavigate hook and the navlink component from the React router DOM package so that we can leverage the relevant React router DOM functionality for navigation purposes. Let's change this div tag to be a navbar tag. Within the navbar element, let's include a container element. Let's include the fluid keyword within the container element. This will ensure that the navigation bar spans the entire width of the web page rather than placed centrally within the web page. Let's reference the navbar.brand React Bootstrap element and set its class name property to the menu-link bootstrap class like this. Then let's include the graduation cap font awesome icon like this as a child element of the navbar.brand element. This icon serves as our application's logo. Let's include the navbar.toggle element here, which will allow the navigation to be shown and hidden through a toggle mechanism made available to the user on smaller screen sizes. So as you can see, Bootstrap is great for responsive layouts. So let's include the nav element and let's style the nav element appropriately. Let's include the button component to represent our login button. The variant property is set to info as a style choice. Let's set the class name property to a Bootstrap class named me-2. This is so that our buttons are spaced appropriately. Let's include the register button, which will appear to the right of the login button on our navigation bar, and let's style the register button in the same way that we have styled the login button. Right, let's open the App.js file and firstly make sure that we are importing the header component into the app component. Then let's include the header element reference just above the home tag within the JSX code that will be returned from the app component. Let's use npm start to launch the application so that we can view what our navigation bar currently looks like. Great. Okay, because our navigation bar is currently white, our brand icon is also white, so we can't currently see our graduation cap brand. So let's change the color to red for now. Great. Okay, so I want to make the background for our application as black and address styling features that I'd like to apply to all of our components. One way we can do this is to include the relevant styling code within the app.css file, which is referenced by the app component. The app component is the parent component for all our bespoke child components. So the styles included within the app.css file will propagate to all the app component's child components. So let's firstly import the Quicksand font from Google through this line of code. We want the Quicksand font to be applied for our entire web application. Let's use the star like this to indicate the following CSS properties apply to the root tag for our single-page application. So let's first set the border-sizing property to border box. If you set the box font-sizing property to border box on elements like this, the padding and border values are included in the width and height properties for the relevant elements. Let's set the font-family property to quicksand. Right, let's create the styling for the app element. Let's set the app root element's background color to black. Let's set the color for our text to white. Let's set the top margin for the app element to 10 pixels. Let's launch the app. Great! Okay, so let's create the component that will house the registration functionality. This component will contain a form that the user can fill out to register the user's relevant details with the system, including the user's name, username, and password. The fields on the form will be name, username, password, and confirm password. We'll incorporate regular expressions into this dialog for the purpose of validating each of these fields. Each of these fields will be validated in real time, i.e., as the user enters the relevant information into the relevant text box controls. So, let's start by creating a folder named Register within the Components folder. Let's add a file named register.js within the Register folder. And let's also create a file named register.css. Let's go to the register component. Let's import the useState hook and the useRef hook into our component. So the useState hook is used to track the state of relevant variables. When the state for a particular variable changes, React detects this and re-renders the relevant component in the user's browser. This useRef hook will be used to reference a text box form control. Let's import relevant React Bootstrap components. Let's import relevant Font Awesome components. Let's use RAFCE to generate the boilerplate code for our register component. Let's declare a constant named nameRef, which will be used to reference the name text box control. Let's use the useState hook to monitor a variable named name. The setName function will be used to change the state of the name variable. The name variable will be bound, as it were, to the relevant text box control, where the user will enter the user's name. Let's include a Boolean variable for the purpose of monitoring the valid or invalid state of the text value entered into the name control by the user. Let's create two variables that are used for the same functionality as the previous two variables that we have created, but are applied to the username text box control. So when the username is deemed as valid, the valid username variable is set to true. Conversely, when the username variable's value is deemed as invalid, the valid username value is set to false. Let's do the same for the password or PWD field, i.e. create two appropriate variables where their state is tracked. Let's do the same regarding the confirm password field, which is used to validate if the confirm password field matches the password field. So I've already prepared the regular expressions for the relevant fields off screen. Please feel free to copy the relevant regular expressions from this location on GitHub. So let's set a constant to the regular expression that will be used for validating the name field. Please remember, if you get stuck or you wish to copy and paste the code rather than following along with creating the code line by line with me, you are able to copy the relevant code from a GitHub repository available at this location. So this regular expression will ensure that the name field has at least 2 characters and no numbers are included. So let's include the regular expression for the username field. The validation criterion for this regular expression means that the username must be between 8 to 20 characters long. No underscore or period characters are included at the beginning, no double underscore or underscore period characters or period underscore characters or dot dot characters are included within the field, and no underscore or dot characters appear at the end of the word. So this regular expression is used for the password field. This regular expression means that in order for the password field to be deemed as valid, a minimum of 8 characters must be included. The password must include at least 1 letter, 1 number, and 1 special character. So let's apply the useEffect hook so that a function that we'll write that is passed as an argument to the useEffect hook is fired when the register component first loads. So the useEffect hook accepts 2 arguments. The first argument is the function to be fired, and the second argument determines when the function is fired. So we want the function passed in as the first argument to be fired when the register component is first loaded. So we can achieve this by passing in empty square brackets as an argument to the second parameter of the useEffect hook. So we want the name control to receive focus when the register component first loads. We can achieve this with this line of code. We'll write the code to create the relevant form controls, including the name control, in just a bit. And this will, of course, be implemented within the JSX section of this component. Let's use the useEffect hook to monitor the state of the name variable, which will be changed with every key press that the user makes within the name text box, which, as I've said, will be created soon. So, to do this, we pass a function as the first argument to the useEffect hook that we want fired when the state of the named variable changes. Then, in order to tell React, as it were, that we only want the relevant function to fire when the name variable's state changes, we can pass the name variable within square brackets as the second argument to the useEffect hook. Note that the test method is executed on the relevant regular expression to ascertain whether or not the name entered by the user is valid or not. The result returned from this line of code will either be true or false. We can then set the state of the valid name Boolean variable to the result returned from the test function. We'll create UI functionality to show that the name field is valid or invalid in just a bit. So we are providing the user with real-time validation feedback as the user types the user's name into the name field. Then let's apply another useEffect hook to perform similar functionality for the username. Let's apply another useEffect hook to check that the password is valid or invalid based on the relevant regular expression. Then we must also check whether the password field matches the confirm password field. Note that within the array, passed in as an argument to the second parameter of the useEffect hook is the variable representing the password field and the variable representing the confirm password field. So this means that each time the password or confirm password fields change, the relevant validation functionality is executed. We'll wire up the relevant variables to their counterpart text box form controls in just a bit, you'll see that the onChange event of the relevant form controls is used for this purpose. Right, so let's create the JSX code within the relevant section of the register component. Let's create a container component. Let's create an appropriate heading. Let's create a main element and a div element within the main element. Please include the relevant class name attributes and values within the relevant elements. Let's include the React Bootstrap form element. So each text box control will reside within a form.group element, which will also include a label control. So let's create the relevant code for the name text box control. The form.label element contains a span element here. We have a ternary operator that shows or hides either a font awesome times icon or a tick icon based on whether the valid name variable is true or false. So this span element will be shown to the user based on whether the span element's class name property references the CSS class named valid or the CSS class named hide. We'll create these CSS classes in just a bit. So if the valid name value is true, the FA check icon is displayed next to the name text box control. Conversely, if the valid name variable is set to false, this span element is displayed to the user, which means the FA times or a cross icon is displayed to the user, indicating that what the user has entered into the name field is currently invalid. Then let's create the text box control for the name field like this. Note that we are setting the ref property to the name ref const. This allows us to reference the text box within the relevant useEffect hook, where we have created code so that the name text box is given focus when the register component first loads. Then the onChange event is wired up to an arrow function that sets the tracked name variable every time the user changes the text entered within the name text box. Let's create the form control code for the username field, which contains similar functionality. Let's create the form control code for the password field. And the confirm password field. Let's create the code for a submit button. So we want to disable this submit button while any of the relevant form fields are not valid. So let's set the relevant disabled property to this Boolean expression. So before we test the validation code for our register form, let's set up the routes for our application so that we can navigate to the register component through the navigation bar that has been created within our header component. So let's open the App.js file. Let's import the routes component and the route component from within the React Router DOM package. Let's include the routes element below the header element. We want the header element to appear regardless of where the user navigates to within our application. so we need the header appropriately displayed outside the roots element. Within the roots element, let's include the relevant roots, where we can tell React Router DOM, as it were, about the paths of our components. We haven't yet created the layout component, so let's do that now. The layout component provides instructions to React, as it were, regarding the overall layout of the relevant components that are mapped to relevant roots. Let's import the layout component. We also need to create a root for the app component, and we must do this within the index.js file. We need to wrap this root within the browser router component, as well as the roots component, like this. Let's go back to the header component and create code so that when the register button is clicked, that the register component is appropriately loaded. Let's create a const named navigate that is assigned a function returned from the useNavigate hook. Let's create a reusable function named handleNav. Let's use the navigate function to navigate the user to a path passed in to the handleNav function. Let's pass in the relevant path to the register component to the handleNav function. So when the register button is clicked, the register component is loaded. Let's test the code. Okay, so to fix this issue, we need to correct a typo here, where we have incorrectly named the regular expression const pertaining to the username field. Great, but in order for our validation to work as expected, we need to create the relevant CSS classes. Let's make sure that we import the register.css file into the register component. Let's open the register.css file and create the code for the relevant CSS classes. Let's create the CSS code for the register-container class, which will make sure the layout for the register dialog is appropriate. We are using the FlexGrid functionality to appropriately handle the layout. Let's include the register-layout class to handle the layout for the register form. Let's include the valid class so that the elements referencing this class are appropriately displayed. Let's include the hide class so the elements referencing this class are appropriately hidden. Let's include a class named invalid-icon to display the times or cross font awesome icon in red. Let's include a class named valid-icon to display the checked icon or tick font awesome icon in green. Let's include a class named register-message. which will style a displayed message to the user that is centrally aligned and in white text. The appropriate text will display once a user has successfully registered. Let's test the UI validation functionality for the name field. Let's test the UI validation functionality for the username field. Okay, so we have an issue. The name field is also being affected. This should not be happening. Let's look at the code. Okay, so within this useEffect hook lies the problem. We are currently using the setValidName function here, whereas we should, of course, be using the setValidUsername function here. So let's fix this. Great. Let's test the password field and the confirm password field validation functionality. Oops, and of course the password control should be of type password and not text. We must of course also make the same fix for the confirm password control. Excellent. So let's go back to the register.css file and make sure our register form is responsive on smaller screen sizes. So let's use an appropriate media query for this purpose. Excellent. So now we want to interface with the Neo4j database hosted in the cloud. So we are going to download the code for the HTTP-based Web API component written in Java to our local machine. So we are going to host the Web API component on our local machines, just to make the development of our application a bit easier. This Web API component is hosted using Spring Boot. In order to be able to run this code locally on a Windows computer, you must ensure that you have the Java JDK installed on your local machine. If you don't yet have the Java JDK installed, please navigate to this URL. Then follow the instructions for installing the Java JDK. Java JDK version 20 or version 17 should be fine. The next step is to clone the GitHub repository at this URL onto your local machine. This GitHub repository contains the Java code for the relevant Web API. So we are hosting the server-side code on our local machines. We are connecting to a Neo4j database hosted in the cloud from our local machines. Please remember the local directory that contains the cloned GitHub repository code. We need to run a command at the command line later on to run the relevant Web API component. As stated before, this will be run locally. Please ensure that you have configured the Web API component correctly to point to the Neo4j database that you have created. If you are unsure of how to do this, please follow the relevant instructions provided in the previous part of this course. The values I'm showing you here will of course not apply to your particular environment. For now, let's create the client-side React code to connect to the locally hosted Web API component. So let's create a folder within the SRC folder named API. Within the API folder, let's create a file named axiosconfig.js. Let's first write code for importing Axios. Let's create the code to set up the Axios client component. So let's add the base URL property and set it to localhost port 8080, which is where we will be able to connect to the relevant Web API endpoints. This Web API component, of course, handles calls to the relevant Neo4j database that is hosted in the cloud. Let's create appropriate code for the headers property. Now, let's go to the register component and import the Axios client component. Let's create a JavaScript function named postData. We must include the e.prevent default line of code for when submitting a form from within a React component, because we'll be using the onSubmit event for the submission of the register form. Then let's create an object that encapsulates the data entered by the user. I'm going to hard-code the roles value here, which is okay for demo purposes, but you'd want to handle this field more appropriately for a production environment. For example, you could have a list of roles presented to the user in a list box control, and the user can select the relevant role from the list box control. Right, so we can write code for post requests using the Axios client component like this. So we are simply posting the object we have just created to an appropriate endpoint created for handling the register post request. We can include basic error handling code through the use of try-catch code, and we can output an appropriate message to the user regarding whether the user has been registered successfully or not. Let's include code at the bottom of the form to display this registration status information. Let's first set the submit success message appropriately based on the response returned from the server-side code. And at the bottom of the register form, let's write the code to display the relevant message saved within the submit success variable. So let's set the min-height property of the app parent component so that it extends to the bottom of the web page. And we can do this by setting the min-height property here so that its minimum height is 100 VH. So the result of this is that the background color will be black regardless of which component is loaded, because the relevant components are all child components of the app parent component. And of course, we must wire up the onSubmit event to an appropriate event handler. So we are wiring up the onSubmit event to the postData method within the form element like this. Okay, so to run the Web API component on your computer, you can run this command at your command prompt. So launch the command prompt as administrator, change the current directory to the root directory of where you cloned the relevant Java code locally. Just a reminder, the relevant Java code can be found at this location on GitHub. So once you have done that, type this command at your command prompt and press Enter. After you press the Enter key, you should see similar information to the information displayed on my screen logged to your screen. Let's run the React code and see if we can register a user. Oops, we have a bug here. We are referencing a control named PWD with the object that we are attempting to post. The PWD field doesn't exist because we named the relevant field password, so let's fix this. We have successfully registered a user. So we are now successfully communicating from the React client code with the Java server-side code, which for development purposes we are currently hosting on our local machines. So we have successfully registered a user. The next logical step is to create the login functionality. Let's create a folder named login, and let's ensure that the first character is lowercase. Within the login folder, let's create a file named login.js, and let's ensure that the first character of the file name is in uppercase. Let's create the file within the login folder named login.css. Right, let's write the code for the login component. Let's reference the login.css file. Let's import the relevant dependencies. Let's import the useState, useEffect, and useRef hooks from React. Let's import the container component from the React Bootstrap package. Let's import the button component from the React Bootstrap package. Let's import the form component from the React Bootstrap package. Let's appropriately import the Axios client component. Let's import the useNavigate hook, the link component, and the useLocation hook from React Router DOM. Let's create the boilerplate code for our component by appropriately typing RAFCE and pressing the Enter key. Great. Let's create a const named navigate and assign it a value returned from the useNavigate hook. We will be able to use the function assigned to the navigate const in code for navigation purposes. Let's assign a value returned from the useRef hook to the userRef const. This will allow us to reference a specific form control within a function. We'll look at this functionality in just a bit. In order to track the state of the username, let's use the useState hook for this purpose. So, user is a variable we want tracked by React, and we must use the setUser function to change the state of the user variable. Let's use the useState hook to track the state of the entered password. Let's use the useEffect hook so that a function executes when the login component first loads. The code for this function simply sets the username field to have the focus, and this happens when the login component is first loaded. Let's create the UI code for our login component within the JSX section of our component. So let's first reference the React Bootstrap container component so that our login form is housed, as it were, within an element that references the container Bootstrap style. Let's create a heading for our login form. For styling purposes, let's create a main element, and within that, a div element. Within these elements are references to appropriate CSS classes. We'll create the code for these CSS classes in just a bit. So like with the registration dialog, we create a form element, and within the form element, the relevant form controls. Within form.group elements. These components are imported from the React Bootstrap package, and we are using them for layout and styling purposes. So each of the form groups contain a label and a text box. So we have the username field and the password field within the login form. Note how we are using the onChange event to change the state of relevant variables as the user changes the text within the relevant text box controls. Let's reference the button component, and this button will serve as the login form's submit button. Please remember, if you get lost at any point while following along, the full code is available at this location on GitHub. The link to this GitHub repository is available in the description of this video. Let's create an arrow function to handle the submit functionality. So let's use this code to reference the values that the user has entered into the username field and the password field. Let's implement basic exception handling through the use of try-catch functionality. Basic authentication has been implemented in the Web API component. Please navigate to this URL if you'd like to learn more about basic authentication. So, in terms of basic authentication, we must encode the username and password values in a particular format before we submit a particular HTTP request to the server-side code. In order to implement basic authentication on the client, we are going to pass the username and password in a particular format through the header of a HTTP GET request for this particular login component. The relevant format for the username and password is username:password. This is essential for basic authentication. We must also encode the username:password value in base64 encoding. We can use JavaScript's BTOA function for this purpose. So let's create a const named b64encode and assign it the value of username:password. That is base64 encoded using the BTOA JavaScript function. The next step is to create an object representing the header information that will be passed to the relevant Web API endpoint. So let's create a const named config and set it to an object to represent appropriate HTTP header information. This object contains a property named headers, which is set to an object with a property named authorization. The authorization property is set to the text value, basic, followed by a space, followed by the base64 encoded username:password text value. Note we are wrapping the value assigned to the authorization property in backtick characters, so that we can interpolate the relevant text value. This means we can include a variable within the backtick characters by wrapping the variable within curly brackets and preceding the curly brackets with the $symbol. Let's create a request to the relevant endpoint using Axios. Note we are passing in the username and password through a HTTP GET request made to the relevant endpoint through the config object. The config object contains the authentication details for the user, which is appropriately added to the header of the relevant HTTP GET request. So, before we test the login functionality, let's make sure that an appropriate route is set up for the login component. So, let's open the App.js file and include the code for the relevant route. Let's import the login component into the app component and include code that represents the route for the login component. Let's open the header.js file and include navigation functionality in this component so that the user can navigate to the login component by clicking the login button displayed on the navigation bar. Let's test the code. We have a few issues here, so let's fix these issues. Please see the relevant GitHub code at this location if you get stuck on any issues. This is the main issue here. This should be useState and not useRef. There are also a few other issues that need to be fixed, so let's fix these issues. Let's run the code. So we have our login form presented to the user, but it doesn't look great. We'll fix this in just a bit. So off screen, I registered a user named Henry Jameson. Please feel free to register your own users while testing. I'm going to test the login functionality using Henry Jameson's credentials. I'm going to use a simple JavaScript alert to ensure that the HTTP status sent back from the relevant endpoint is 200, meaning that the HTTP request has been successfully processed on the server. Excellent! We have received a response with a status code of 200. So we've received a HTTP response with a status code of 200, meaning success. So next, let's style the login screen appropriately. Let's open the login.css file. Let's style the CSS class named login-container. We are using the flex grid for styling and layout purposes. The flex grid is great for creating responsive UI code for various screen sizes. Let's create the login-layout CSS class. We are also using the flex grid functionality here. Note that we are setting the flex direction property to column, which means the relevant elements will stack one on top of the other in a column layout. By default, if the flex direction property is not set, this setting defaults to row. This means the relevant elements are presented one next to the other in a row layout. Let's give each of these form.group elements suitable margin bottom settings using Bootstrap so that we are creating appropriate spacing between the form groups so that our layout here is a bit neater. Great! Let's include an error message at the bottom of our form for if something goes wrong during the authentication process. So let's set the state of an appropriate error message based on the response provided by the server. So if a status code of 200 is returned from the server, the state of the error message variable can be set to an empty string. Or if the status code does not indicate success or an error is thrown, we can set the error message variable appropriately to indicate that the login has failed on the server. If an exception is thrown, we can include the error message that has been caught within the try-catch block. Then let's output the value stored in the error message variable to the screen at the bottom of the login form. let's style the error message display appropriately. So to test this, I'm going to force a 404 exception, meaning that the relevant endpoint is not found, by changing the endpoint path to something that is incorrect. Great. Lastly, let's ensure that our login form looks good on smaller screens. So to do this, within the login.css file, let's include appropriate media query functionality. Let's include code here to automatically navigate the user to the home page once the user has successfully logged in. Excellent. Great, so once the user has been authenticated, we want our other components to know, as it were, that the user is logged into the system. So the best way to do this is through the use of context. React context is a way to manage state globally. So very basically, we use React context so that other components will be able to retrieve a value from a global store and assess whether a user is logged into the system or not logged into the system. For more information about React context, please navigate to this URL. So in order to create context, let's create a folder named context within the SRC folder. Within the context folder, let's create a file named AuthProvider.js. Let's import the create context function and the useState hook from React. Let's set a const named authContext to a value returned from the createContext method, like this. Note that we are passing an empty object to the createContext function. Let's write code to export a component named AuthProvider. Note that this code simply means that the auth variable and setAuth function will be passed down to all components that are wrapped by the AuthProvider component. So this makes these accessible to the relevant child components that are wrapped by the AuthProvider parent component. We'll look at this in just a bit. So what this means is that all relevant components will be able to access the auth variable within all relevant child components. If the auth variable is not null, this means that the relevant user has been authenticated, i.e. logged onto the system. Of course, the state of the auth variable is managed through the use of the useState hook, implemented within the AuthProvider component. Let's create a folder named hooks within the SRC folder. Within the hooks folder, let's create a hook named useAuth. This code basically allows relevant components to access the auth context, which means access is provided to the auth variable and the setAuth function. The setAuth function, of course, is used for changing the state of the auth variable. So to log in, you change the state of the auth variable, and to log out, you appropriately change the state of the auth variable by setting it to null. The auth variable state indicates whether the user is logged into the system, and the setAuth function can be used to change the state of the auth variable. So the setAuth function can essentially be used to log the user into the system or out of the system. Let's create a hook named useAxiosPrivate. So the code for the hook is created so that the client code can retrieve an appropriate Axios client object that automatically includes an appropriate HTTP header containing the logged on user's credentials. These credentials are appropriately formatted for basic authentication. So the returned Axios client object from this hook must be used for accessing protected resources on the server, i.e. retrieved through the relevant API endpoints. These protected resources require basic authentication to be performed before returning relevant data to the client. Now, the code here creates what's known as an interceptor. So if the useAxiosPrivate hook is used from within client code to reference the Axios client, the login credentials are automatically injected into the header of the relevant HTTP request. So this means that the client code doesn't need to inject this authentication header information every time a HTTP request is made to an endpoint. This interceptor code does this automatically. Just a reminder, if you get stuck creating this code, please reference the relevant code at this GitHub repository location. So the next step is to open the index.js file and wrap all the relevant components within the AuthProvider parent component. As discussed, this allows the child components, or makes provisions for the child components, to easily access the auth variable so that the relevant component can access whether the user is logged into the system or not logged into the system. So let's look at how this works. Let's open the home.js file. Let's import the useAuth hook. Let's use the useAuth hook to return the auth variable and the setAuth function from the relevant context global store. Now, within the UI JSX code section of the home component, we can check the auth variable to see if the user is logged into the system, like this. So if the user is logged into the system, the code displays a message on the screen. You are logged in. If the user is not logged into the system, the code displays the hero image to the screen. So let's open the login.js file and use the useAuth hook to return the setAuth function from the context. Let's use the setAuth function to assign an appropriate object to the auth variable. This object contains the username and password. So once the user is successfully authenticated, an object containing the user's username and password is passed into the setAuth function, which effectively changes the state of the auth variable, which indicates, of course, that the user is logged into the system. So you can see that now this global context can be used to retrieve the username and password from this object, i.e. the object that we have just passed in to the setAuth function to change the state of the auth variable. The username and password can now be injected into the header of HTTP requests through the Interceptor functionality that we have implemented in the useAxiosPrivate hook. Let's run the code. Let's register a new user named Brandon Lowe. Okay, the password here is password1!. Let's then log into the system. Excellent. So let's create our logout functionality within the header component. Let's retrieve the auth variable and the setAuth function from the useAuth hook. So if the auth.user property is not null, this means that the user is logged into the system. So we want a logout button to be displayed in the navigation bar rather than the login and registration buttons when a user is logged into the system. We only want the login and registration buttons presented to the user when the user is not logged into the system. Let's create a function for when the logout button is clicked. So let's create this logout function. Within this function, we can simply set the auth variable to null by using the setAuth function for this purpose. This effectively means that the user is now logged out of the system. Then let's also implement code to navigate the user to the home component. Right, let's log into the system. Great! Let's log out of the system. Excellent. So let's create the code within the home component so that when the user is authenticated, a list of courses is displayed to the user rather than the hero image. Let's create code using the useState hook so that React monitors the state of a variable named course data. We can change the state of the course data variable using the setCourseData function returned from the useState hook. Let's use the useAxiosPrivate hook to return a reference to the Axios client that we are going to use to request a list of courses from the server. Note, we are getting a reference to the Axios client using the useAxiosPrivate hook. Because the useAxiosPrivate hook contains functionality that will automatically inject the logged-on user's credentials into the header of the relevant HTTP request. So each request to the server requires the user's credentials, so that basic authentication can be appropriately performed. This is because the course data is a protected resource, so the user must be authenticated before this course information is passed from server to client. Remember, implemented within the useAxiosPrivate hook is Interceptor functionality, so the HTTP request is intercepted and the relevant authentication information is injected into the header of the HTTP request before the relevant HTTP request is made to the server. So let's create a JavaScript arrow function named fetchCourses. So here a GET request is made, and once the results are returned, we are using the setCourseData function to appropriately change the state of the course data variable. This results in the home component re-rendering, which means a list of courses will be displayed on the UI once the data becomes available, and the setCourseData function is appropriately called to change the state of the course data variable. We'll implement the code for displaying the course data on the UI in just a bit. Let's use the useEffect hook to call the fetchData function when the home component first loads. But we only want the fetchData function to be called if the user is logged into the system. Let's display the course data value in an alert to test our HTTP GET request. Let's run the code. Oops, we currently are not importing the useState hook. Let's fix this. We now have a 404 error. This is occurring because we need to include a / at the end of the endpoint path here. Let's try again. and we are getting the expected JSON results with a now alert. This means our HTTP request is working as expected. Right, so let's write the code for displaying the course data on the UI. So in the return section of the home component, let's implement the code for displaying the course data. I'm going to create this code fairly quickly with minimal explanation. So we are using the map function here to iterate through the courses list returned from the server. This courses list is stored within the course data variable. So I'm deliberately not providing a lot of explanation here. Please note that this part of the course is not a detailed guide on Bootstrap or even React for that matter. This part of the course has been created for the purpose of placing the advantages provided through the use of the Neo4j graph database management system in the context of a web-based application. Please feel free to copy the relevant code from GitHub. The first map function, let's refer to this as the parent map function, traverses the list of courses. Note that we are outputting the title for each course within the parent map function. This title property will be returned from the relevant endpoint. Within the parent map function, another map function is implemented that traverses a list of lessons. The lessons make up the relevant course. So we are outputting the title of the course as a heading. A list of lessons is outputted for each of the relevant courses underneath the relevant heading. So essentially the data is grouped by course. The title for each course and the course's lessons are outputted to the UI. Bootstrap is being used for layout and styling purposes. Note that we are setting the key property for this element to the identifier property for each course. When using the map function, it is always a good idea to appropriately set the React key property for the relevant element like this. This helps React to be more efficient when considering the component. We are also appropriately setting the key property for the element here related to each lesson. We are setting the key property here to the identifier of each lesson. Let's test the code. Okay, we have an issue here. So to fix this issue, we need to import the link component from the React router DOM package. We are using the link component to wrap the title for each course. This is because we are going to create a component responsible for displaying course details for each individual course in a bit. Once this is done, we'll point this link to the relevant course component, where the details for the relevant individual course will be outputted. This will allow a user to click the header for a course and for the course details for the relevant course to be displayed after the user clicks the relevant link on the home page. You can see we have 4 courses currently saved to the system. So let's create a component that displays the course details for a particular course. So, from a UX, user experience perspective, the user will click on the course heading on the home page and will be navigated to a component that displays the course details for the relevant course. Let's create a folder named Course and a file within the course folder named course.js. Let's generate the boilerplate code for the course component. Let's open the App.js file and include an appropriate root for our course component. Note that this component accepts a parameter passed into the course component, which is an identifier for a particular course. So to tell the React router DOM system, as it were, about the relevant identifier parameter, we can include a colon followed by the name of the parameter, identifier, at the end of the relevant route path, like this. Let's go back to the course.js file. Let's include the relevant imports. I'm not going to explain this import code, as we have already covered this while creating code for the other components. All except for the useParams hook. We are going to use the useParams hook to extract a parameter value that will be passed into this component from the home component when a user clicks on a course heading. So let's create a value from the useParams hook. We can then use the params object to retrieve the name of the parameter that we named identifier. Let's create a tracked variable named course data. We can use the setCourseData function to change the state of the course data variable. Of course, when the state of the variable returned from the useState hook is changed, this results in the relevant component being re-rendered. Let's use the useAxiosPrivate hook to get a reference to the Axios client, where an interceptor is employed to inject the user's authentication details into the HTTP header for any HTTP request made using the Axios client returned from the useAxiosPrivate hook. Let's use the useEffect hook so that we can execute code that retrieves data for the relevant course when the course component first loads. Let's use an alert to output the results returned from the relevant GET request. Within the home.js file, let's include the appropriate path to the course component within the relevant link component like this. Note we are including the course identifier as part of the path assigned to the toProperty of the link element. Let's test the code. Great. The results are outputted through a JavaScript alert. The JavaScript alert is, of course, just used for testing purposes. Let's create the UI code in the part of the course component that returns JSX code. So the code is very similar to the code within the JSX section of the home component. So to speed things up, I'm just going to copy and paste the relevant code from the home component into the course component. Then let's adapt the code appropriately for the course component. So the difference between the relevant code in the home component and the relevant code in the course component is that only one specific course is displayed in the course component, whereas a list of all courses are outputted from the home component. Just a reminder, if you get lost while creating the code for any part of this application, please reference the code that can be found at this location on GitHub. Note that for our course component, we are also including the instructor that teaches the relevant course. This data is returned from the server in the teacher property. So the course component only ever returns one course, rather than a list of courses that are displayed within the home component. So we copied this code from the home component, which is currently incorrect for the course component. We need to replace the D variable here with course data, because the D references an item in a list of courses in the home component. This course data variable represents one particular course. Excellent. The next component that I want to create is used for the purpose of displaying only the list of courses in which the logged on user is enrolled. So let's create a folder within the components folder named EnrolledCourses. Within the EnrolledCourses folder, let's create a JavaScript file named EnrolledCourses.js. Let's copy and paste the relevant imports from the home component. So for this component, I'm going to copy most of the code from the home component, as the code is very similar. The only difference is that we are calling a different endpoint on the server to get the relevant course data. In this case, only a list of courses in which the logged on user is enrolled will be displayed to the user. Just a reminder, you can of course get the finished code from the relevant GitHub repository. Let's include an appropriate root component for the enrolled courses component within the App.js file, like this. Now let's open the header.js file and include code so that a link to the home component and the enrolled courses component will appear within the navigation bar at the top of the UI. In order for our links to be displayed in white text, let's include the following properties within the navbar element, like this. So on smaller screens, this navigation bar doesn't currently look very good. So let's wrap the relevant navigation elements within the nav collapse element. So that on smaller screens, the navigation bar responds appropriately. Great! We copied this code from the home component, and we of course don't need this code that outputs the hero image in the enrolled courses component. So let's delete this code here. Currently, when we click on the Enrolled Courses link, no data is displayed. And this is an expected result because the logged on user has not enrolled in any courses. So let's create the functionality so that a user can enroll in courses. We'll implement this functionality from within the course component. So let's create code that displays a button within the course component that is labeled Enroll. This button must only display if the enrolled property for a particular course object returns false, which denotes that the logged on user is not currently enrolled in the relevant course. So when this button is clicked, we want a function named Enroll to be executed. The code for this enroll function will of course enroll the logged on user into the relevant course. So let's create the enroll function. You can see that we are using a HTTP post request to post the course identifier wrapped in an object to a specific endpoint. The server-side functionality written in Java interacts with the Neo4j database management system appropriately in order to create the appropriate relationship between the user and the relevant course. So if the endpoint returns a status response of 200, meaning success, let's display this message to the user, which simply thanks the user for enrolling in the chosen course. Then let's include code to navigate the user to the Enrolled Courses component. Let's test this functionality. So each of the lessons listed for the enrolled courses must have a play button icon next to it. When the user clicks the play button icon, the lesson that has been created as a YouTube video will be displayed to the user through the video component that we are about to create. So the play button is implemented using the Font Awesome icon component. The font awesome icon element is wrapped by the link element. The link element's toProperty is set to the path of the video component that we will create. The lessons identifier is passed in as a parameter to the video component when the relevant video link is clicked. The play button icon denotes this link on the front end. So in the home component, we are currently handling what to output to the screen. The hero image is displayed when the user is not logged into the system, and a list of courses is displayed when the user is logged into the system. When the user clicks the Enrolled Courses link, this is currently not being handled appropriately. We want the login screen presented to the user if the Enrolled Courses link is clicked, while the user is not logged into the system. Then when the user logs into the system, we want the user to be navigated to the Enrolled Courses component rather than the home component. So let's implement the code to handle this scenario. Let's first create a component within the Components folder named Required Auth. This component is responsible for navigating the user to the login screen if auth is null, i.e., the user is not logged into the system. Then let's open the App.js file and wrap the enrolled courses route with the required auth element like this. So the user will not be able to access the enrolled courses component unless the user is logged into the system. If the user tries to click the relevant link, the user will be presented with the login screen. So this forces the user to log in order to see the user's enrolled courses. And once the user logs in, the user is navigated directly to the enrolled courses component, which means the user can see the list of courses in which the user has been enrolled. Within the login component, we need to create the navigation code so that when the user logs in, the user is navigated to the component that the user tried to access prior to being redirected to the login screen. In this particular case, this would be the enrolled courses component. Let's test this code. Great! So the last component that I want to create is, of course, the video component. This component uses the React Player component to play the lessons that have been created as videos on YouTube to the user. Let's create a folder named Video. Let's create a file within this folder named video.js. And let's create another file within the video folder named video.css. The code for implementing the play video functionality is very basic. Let's use the useParam hook so that we can retrieve the YouTube video ID that will be passed into the component, like this. Let's open the App.js file and include the appropriate route, so that the React router DOM system, as it were, knows how to navigate the user to the video component, as well as pass in the appropriate parameter to the video component. The parameter value will be the YouTube video ID pertaining to the relevant lesson. Let's include the React player element appropriately within the video component, so that the relevant YouTube video plays immediately. We are setting the playing property to true for the React player element for this purpose. Then let's set the URL property appropriately to point to the relevant video on YouTube. Note that the URL includes the YouTube ID that is passed in as a parameter to this component. Let's style the video component appropriately. Right, let's test the code. I'd like to introduce you to this exciting new Unity for Beginners course, where we'll create a game using Unity and C# over a series of videos. All the software that we'll use, including Unity and VS Code, can be downloaded free of charge. This course is totally free. Hi and welcome. I'm Gavin Lon. The rigid body component allows us to apply physics to a game object, for example, gravity. But we are going to write code in the update method to apply a forward force to the player game object in response to the user pressing down the W key on the user's keyboard. So to improve the user's experience, you can include a spinner that appears to the user while data is being loaded. So in fact, the last component that we'll create could be the spinner component. So when the data is loading, we present the user with a spinner. And then when the relevant data becomes available, the spinner component disappears and the data is displayed to the user. So for this purpose, I've created a spinner component. Please reference the relevant code on GitHub if you'd like to include this spinner functionality within your application. I'm going to fast forward the creation of the spinner component, as this is purely a bonus piece of code that you can study at your own pace if you are interested. To implement the spinner, we are simply creating a React component relevant CSS code to style and animate the spinner, and functionality within the relevant components to appropriately show and hide the spinner. The showing and hiding of the spinner is implemented using a Boolean variable where the state of the relevant variable is tracked through the use of the useState hook from within the relevant components showing or hiding the spinner. Please review the code in detail at the relevant GitHub repository location. The link to the relevant repository is available below in the description of this video. We can pass in the relevant Boolean value as a prop to the spinner component to indicate to the spinner component to be visible or hidden, like this. Let's integrate the spinner component into the enrolled courses component. Hi and welcome, I'm Gavin Lon. This is part 2 in a course where we'll create a game using C# and Unity. In part 1 I demonstrated the potentially making the game at runtime more robust. For details on C# data types, I've included a link to a C# tutorial on C# data. So I'm going to finish the code for this application by styling the header of the courses displayed in the home component, the course component and the enrolled courses component. I'm including the relevant CSS classes within the App.css file so that the classes affect all of these components. I know the UI for this application is not beautiful, but the purpose of this part of the course is to place an application that takes advantage of a Neo4j graph database management system for the purpose of managing relationships between data entities in the context of a web-based application. My challenge to you is to fork the GitHub repository that contains the code that I've demonstrated in this part of the course and abstract the common parts of the JSX code contained in the home component, the course component, and the enrolled courses component into relevant child components. One suggestion is to create a reusable child component for an individual course. You can then use appropriate props to dynamically customize the new child course component based on its context, i.e. its parent component. For example, in the enrolled courses component, a play button appears next to every lesson for each course. Whereas in the home component, these play buttons are not included next to any of the lessons for each course. So the new course child component will need to account for these two scenarios and dynamically output the appropriate JSX code. I hope that you have enjoyed this part of the course and have learned a little bit about creating a client React application that interfaces with a web API component through Axios, where basic authentication is employed. Thank you and take care.